is taking place, and this is our 9th year, Cypher 2025. I'm Shruti Tripathi, and I'm honored to be your host once again as we dive into the exciting second day of this remarkable conference. I hope you've had your coffees. I've had my coffee, and I'm feeling very fresh. Cypher 2025, the flagship event of AIM Media House, is now in the 9th edition with a thrilling focus on generative AI. We're so glad to have you all here to continue exploring the future of AI together. Let's kick things off with the opening video of Cypher, everyone. Let's have the video.
India, with over 1.4 billion people, thousands of languages, untapped potential, is on the cusp of a new technological era.
How do we look at deciphering the India story through the prism of greater usage of AI?
Artificial intelligence.
Artificial intelligence.
Artificial intelligence.
Artificial intelligence.
There is one large society in the world that seems most enthusiastic to transform with AI right now. It's India.
India has successfully built a digital public infrastructure for over 1.4 billion people. India leads in AI adoption. We have one of the world's largest AI talent pools.
Yet, the journey is not without its shadows. Access, bias, infrastructure, inclusivity.
I think India may be our largest market in the world.
We've seen a massive uptake of ChatGPT.
Yeah.
It's almost our second largest country in terms of users.
For India, this is a moment. India has an extraordinary base of developers.
We have the highest concentration of AI talent in the world.
From consumers to creators, building solutions that India and the world can use. This is Cypher. This is the moment where India decides not just what it will build, but who it will become.
Over the next 2 days, we continue the defining chapter in India's AI journey. Cypher 2025 has grown into the largest AI conference in the country, a one-of-a-kind platform that took no time to become a groundbreaking success. This year's theme, Make AI in India, goes beyond a simple call to action. Cypher brings together the entire Indian AI community, researchers, practitioners, policymakers, and entrepreneurs, all united to build solutions that will shape not just India's future, but the world's. Welcome back to Cypher 2025, where India makes AI happen. Before we dive into the exciting sessions ahead, a quick announcement for the conference attendees. We all get excited about the contests at the conference. So this is the time that you can actually win exciting prizes. Cypher is running some amazing contests. Kick off day 2 with bingo, packed with exciting challenges. Join now and win some fantastic prizes. Don't miss the treasure hunt today. It will be starting at 4 and it will be ending by 5 in the evening. It's a great way to have fun and get moving. Register between 11 a.m. to 12 p.m. At the stall, the top 30 teams will be selected on a first-come, first-served basis. So do make sure that, if you are attending the conference right now, send some team member at 11 who could be free or is wanting to take a coffee. I mean, if he's taking a break, might as well. Ek teer se do nishan hai. Calling all social media fans to gather your friends to dive into the adventure is actually going to be a great memory to make. Today, we are honored to welcome none other than Leander Pease. And we are privileged to have him with us for the Minsky Awards, where he will be presenting awards to our winners, and also a fun fireside chat will be happening. So do make sure that you become a part of it. We also have with us the voice of Indian sport, Charu Sharma, a celebrated sports commentator, anchor, and the man behind the Pro Kabaddi League, who will be our quiz master for the AI quiz on the other day, that is tomorrow. And on the last day, day 3, we're also going to have Kenny Sebastian, one of India's most loved and celebrated stand-up comedians. And it's going to be a great time, I'm telling you this. We've manifested this somewhere down the line together. Okay. Be sure to visit the Expo stage where we're hosting more than 100 booths. So it's going to be a combination of everything that you could get under one hall. And this experience is not to be missed. So ladies and gentlemen, make sure that you also explore in the time that you get in between. We also have a speed networking session right next to the Expo stage area, near the tea and coffee counters. This is your chance to meet and connect with fellow AI leaders, founders, and professionals. The session runs for only 45 minutes and is on first come, first served basis. So again, the session is going to be starting in the morning, it's at 10:45 and it ends by 11:30. In the evening, we're starting at 3:45 in the afternoon and we end at 4:30 p.m. So do make sure that you become a part of it, because it's going to be a very fun group of tech people, AI people coming together and giving out information, and a very great chance to actually, if you have any questions, and I'm quite sure that you might have a lot of questions, to clear those questions and have a great day, right? Before we start the sessions, let's take a moment to express our heartfelt gratitude to the incredible sponsors who have made Cypher 2025 possible. Cypher 2025 is presented by NextGen, powered by GenPact in association with Snowflake, ecosystem partner, Startup of Karnataka, Government of Karnataka. Platinum sponsors Cisco, 11 Labs, LinkedIn, Tredence. AI Cloud partner NASA. Gold sponsor IXA, EPAM, Tiger Analytics, Uber AI Solutions. Silver sponsor Epsilon, Lowe's, Skyflow, Data Palago. Our exhibit sponsors are Alstom, Burns McDonnell, Carrier, Imalfa, EXL, Firebolt, Jigsaw, Initia AI, Kritima IQ, Nav AI, New Relic, Orme, Cybernova, SetNext, SmartKey.
Hello? Yeah, perfect. Slides there. Perfect. Is it? Okay, it's there. Okay. Got it. Perfect. So, hi everyone. I am Mugilan. Thanks for the wonderful introduction. Right. So, before I just start, I just want to very quickly a show of hands of how many people have actually flown drones. Perfect. About 20% of them, right? I guess drones has been around for about a decade now. I guess everybody has seen drones. Where you guys have seen drones? More in concerts, wedding halls, concerts? Any other place anyone else seen drones? Yeah, I heard concerts. I guess I heard weddings. So actually, drones have been everywhere, right? In the last decade or so, we've been seeing it almost in every place in touching our lives. We don't just see it. It's there in mines, it's there in, we've heard of it in Operations Indoor. Right, a decade ago, people were thinking, oh my God, drones, we don't know what to do with the tech, right? We have heard it only from the American standpoint, predators and so on, but very recently we have seen it being used in India, in our home turf. Anyway, quickly, right? So I wanted to ask everyone, what do you think is common amongst all of these work sites, right? I mean, sites of sorts. I have a mine, I have a utility park, I have a national border, and some power lines. What do you think all of them have in common? Surveillance. All are secular areas. Isolated. Dangerous. Yeah, they need great. So all of you are right. So all of them happen to have people wanting to cross over, right, and steal something or be there, right? And almost all private or Indian infrastructure or global infrastructure has great amount of value, right? And we have seen so many times over a period of our, our journeys on this planet that so many people have intruded borders, right? And it's become the biggest, trouble for all of us as a country and as private owners of work sites and things like that. So why is it actually a problem? It's a problem because of the fact that we really don't know, you know, how many blind spots are there. The boundaries are too long. It is absolutely impossible. You might, we have had cases where people have put in so many security guards. We have the largest, army in the world, right? We have the largest security forces across the board in the country, right? And we still have this problem, right? And that's simply because we use, unfortunately, all we have is our own intelligence, right? Till date, right? And we also have, and we have a big scale across hundreds of kilometers of this thing. This is the problem, right? More or less. So okay, so this we all know, right? So what are we doing different, right? What, given 2025, given we have AI, given whatever, what can we do, right? So that's mostly the context. That's mostly what I'm going to talk about, right? So we believe that this is a quick video, right, of what we kind of did, right? I'll just quickly play it and then you can see it, right? So we have a chat bot, right? And that's actually a drone which just took off, right? And what we managed to do, right, in a particular work site, in a solar site at around 3 a.m. in the morning, was intruders trying to pick up, cable, and they were, happily scooting away in their motorcycle. And what we could do was very quickly send this drone, follow them for about 4 to 5 kilometers before they actually got caught, right? And all of this happened quite autonomously, right? So very quickly, right? Let me just go back, 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 go back. Become smarter with time, right? Once you know the work site, you always call your favorite security guard, asking him, is there an intrusion in this place? The field officer or digital field officer will get even more smarter. It will start detecting things and it will start going to those locations autonomously as it learns, right? So things become only better with time, right? And that's something that we are actually building. So what does all this mean, right? So given all of this, given if we were to enter into this era of digital field officers with drones autonomously flying and gathering intelligence, and we actually talking to it more than talking to people, right? So what does all this mean? So we have about, I don't know, 300,000 kilometers of borders. We have about close to 1 million work sites globally, right? And all of it can change, right? The way we govern it can change, the way we monitor it can change, the way we actually interact with people on field can change. It's a very empowering thing for everybody involved, right? All our customers today, at least the guys who have implemented it today, are calling this more than calling their field staff, right? Even the field staff is calling this more than going and doing the work themselves, right? So everybody, I think, is benefited through this, change of actually employing digital field officers, using drones and software rather than actually employing people and making them do the hard work. Right, and we are all guilty of it. We all, personally, me, I'm very guilty of it. Actually, calling people up and asking them what's happening on the site. Are you there? Are you not there? Why are you not doing this? Give me that photo. Give me this photo. For a construction site, we are all guilty of it, right? I think we can live without that guilt moving forward, right? So that's mostly what I have for you here today. And this is a small set of the team. We don't have a group photograph. We are about 50 people. We're based in HSR, right? Very happy to speak to everyone here offline, right? We're a Bangalore-based company. Been out around for quite some time now, right? That's me and the first, right? So of course, anybody wants to talk to me, please. You can book an appointment or you can send me an email. I'm here for the rest of the day, but that's mostly what I had for you. I didn't want to bore you guys in a morning. I wanted to keep it short, quick, and leave you guys to think about what is possible, right? But that's about it. Thank you.
Ladies and gentlemen, if you have any questions, you can please go ahead. Can you please pass the mic?
Hey, hi Mugilan. It's here. Hey, yesterday there was a talk on Galaxy Eye. It means like coming up with a hybrid imaging satellites, which will also try to talk about surveillance. In case if they come up with good resolution cameras, then what value will the drones add there?
Great question. Actually, we're complementary, right? Satellites and drones, right? The biggest value for drones, right, is the fact of on-demand, nature of it. So today, if you want to do something, right, you prompt it or you pick up a drone, you can actually do it much faster. Satellites usually have a 1 day or 2 day or whatever the revolution, turnaround time, right? So that's one of the reasons when you have daily or, if you want instantaneous intelligence on the field, you would rather believe, you would want to talk to a drone of sorts. Yep.
Hi. Thiru, this side. This side.
Yeah, hi.
Yeah. Thanks for the presentation. One question, since it talks about securing our borders, just wanted to understand in which sectors or different sectors you have worked with, whether it's Indian Air Force, Army or the Navy, and what are the challenges actually Skylabs have solved for the different services?
Security, of course, we have worked from a defense standpoint, mostly on surveillance related activities, right, across some regiments. But mostly we have also done security across, for all these work sites, right? Most of our customers employ us to also secure their borders, right? Because we see a lot of thieving happening in all their work sites of sorts, right? Including railway. There's a lot of cable theft which happen rail, right? There's a lot of cable theft happening solar. There's a lot of physical theft that happens in these sites today. So we have solved for all of those security and surveillance use cases, other than all the productivity ones which I mentioned. Yeah.
Thanks. Hi, Thiru.
Hi.
My name is Soumya. I have a technical question. How do you secure the network? Because when you have the surveillance drones, it's a hack, prone. So very difficult to secure the network, especially on the borders. Plus, you would relay the data back to your site to basically make that decision. So how do you guys do that?
So perfect. So good question, right? So mostly in the borders, it's a much more harder question to answer, right? I'll tell you the architecture today, right? So how it works today, right? So one of the things is a drone and a docking station has an RF, right? From there, it's a line connection, right? We actually have a cable going from the dock to the cloud, right? We are doing a lot of edge computing on the box device itself, right? Which kind of helps in autonomous decision making. As much as possible, we try to make decisions at the edge, right, and not really take it back, right? With respect to hacking the drone itself, if you want to, if it's communicating of sorts, typically enterprises really don't have any sort of problems, right? Nobody hacks into drones in enterprise sites. In borders, it is a challenge, right? We have not yet encountered it, but it is a vulnerability that we are trying to solve for, right? Especially when if you can track into the RF itself, right? That's really the challenge that we have to solve for, right? Because other parts of data communication and everything else is okay. We can live without it because you can autonomously, make decisions on the edge, right? Or at least head to that direction, right? Yeah.
Hi. Thanks for the talk. My question is, so you mentioned multiple areas in which you work. So one is in regards to solar. There it's compared to you go over the solar panels and you are able to identify which are working, which are not working. How difficult is the compliance part, as in some mines, or monitoring how much has been excavated and whether people are following the human safety protocols, because it's very difficult to identify those portion compared to when monitoring over the solar image, like solar the array, and figuring out whether it's working or not, how difficult that part is.
Perfect. So great question, right? So for a particular mine, what is necessary is basically we do another step which I somehow skipped. Sorry for that. Called photogrammetry, right? We collect overlapping images and actually create a three-dimensional map of the work site, right? And that particular map is about 3 centimeter per pixel resolution, right? And that is both X, Y, and Z. So you'll actually get a nice 3D model of the mine, right? That 3D model of the mine is what we use for all sorts of volume computations or measurements and so on and so forth, right? So, and that's again, photogrammetry is the process. It's basically converting images into 3D point clouds, right? And once you have the 3D point cloud, you can very quickly, compute volume and understand compliance and do all of that, right? Now you're chatting with an actual 3D point cloud of sorts. So we generate that for mines. I hope I answered your question, right? So.
Hi. Hi,
Hi.
I'm Rishabh from Google.
Hi.
Great presentation. I just wanted to ask one thing, that one of the challenges in the forward areas, especially with the defense, is logistics and supply. So is that some use case which you are looking into? Coming from an experience that I was in the army for 10 years, I served there, and so I just thought, like, it is one of the challenges which we are still not able to solve for. So is that something you're looking for? If yes, then what are the main challenges or complexity you're thinking that may arise?
We definitely, I mean, over being a decade of sorts, we were approached by a bunch of hyperlocal companies, right, on this. It is possible to do. I'm not going to deny it's not possible to do. We have not yet put our eyes and mind into that at this moment, right? We of course have an experience of actually building some of these things, but we have not yet gone in that direction as of yet, right? But yeah, in the next couple of years, we will head in that direction. I think the biggest challenge, and if I have to answer your question fairly, the biggest challenge what we like to solve is basically the challenge of payload, right? I think what people kind of miss the entire thing is the fact that, okay, people think about speed, people think about access, range, but I am the opinion that if we were to carry 10, 20 kgs even for 1-2 kilometers, and you can just solve for that itself is of tremendous value, right? Because I think that, and that's the direction what we believe that is more value to be achieved, and that's actually happening, right? In adjacent sectors like in agriculture, in drones, they're actually 10 liter, 30 liter, 50 liter, spraying drones out there, right? If we were to modify that and add some intelligence on that, I think it is very possible to actually go down the path of saying, okay, can I carry 10 kgs for about 2 kilometers, right? I think that is the direction, that is the kind of vision we have for that construct, rather than thinking about range as a as a bigger problem, right? That's my 2 cents. Yeah.
Last two questions, ladies and gentlemen. Any other questions left?
Great. Yeah.
Hi. This side.
Hi. Hi.
Myself, Devesh from Kitchen 365. I'm just a bit curious about one thing you said that the drone can take off and then can scan the entire facility and then can get you the status report, right? So I just wanted to know when it scans and gives you like how much percentage of work has been completed compared to the expected one and everything in the detailed analysis. How exactly you do it, like in terms of imaginary view, or you are like doing it in terms of like good analysis of the how much percentage it is completed or something, on what data parameters you are evaluating from that scan or anything?
Perfect. Great question, right? So when you talk about progress in a site, right, there are several, progress parameters, right? And our experience says that, about close to about 50-60% is visual, right? More than 50%, more than 60% is visual, right? So by visual, and I think another 20 odd percent is quote unquote measurable, right? The remaining 20% you can't see or measure. It is, something which some expert has to come and actually go see, okay, is the electrical connection, is that plug put in somewhere, right? Or is it between the walls or something you can't see, right? Somebody needs to go inspect it even closer, right? And progress is also defined by plan versus actual, right? So we get plans from, our customers. We don't generate plans, right? We ask them, okay, what is your plan? What are the parameters, right? And we kind of bucket into, okay, what needs visual, what needs measurement, and what cannot be measured using a drone. Maybe somebody has to physically going there and actually touching it, or actually, having some other equipment, right? But most of the cases than not, what we have noticed is, guys, if there are 70-80% of progress, which data parameters, which can be both visual as well as measurable, that is the one we target, and that's what most of our customers actually want. And then we update this back into their Primavera systems and whatever else construction management systems that they may have, right? And that is how we actually get plan versus actual. So most of our customers are in mines and solar parks and construction, and these are all open to air kind of places, right? And it's quite easy to, determine whether progress has actually happened or not. At least 80% of progress has happened or not, right? And that's more than sufficient for, people to take decisions. Yeah.
One last question.
Yeah.
So in your visuals, we did not see the tethered drone, which is used in borders, and that is possibly a cheapest solution vis-a-vis what we saw from satellite monitoring or
correct
the demand-based monitoring which are doing
correct
in drone. So it is, are they dying as a dying market, tethered drones? Because we are doing projects in the tethered drone side of things. Yeah.
Yes, so tethered drones has its own. I think, I think in the drone ecosystem, I don't think anything is a dying product, right? I think we are just evolving, right? I'll give you an example of this, because when we started in 2005-06, there were like, people were talking about small drones, then they were like big drones, then they were tethered, then they're agriculture. So it's like almost like a full category of devices which are coming out, right? Unfortunately, we've been thinking about phones, computers. We have only one form factor, so we think only one thing. But it's more like an automobile, right? It's like an SUV, this, that, like, it's like different varieties of cars. There are like, I'm sure there'll be like 10, 20, 30 different categories of drones which are going to occur, right? And each one of them will have their own special niche use case. Tethered drones are, as you might know, it's a case where, it's constantly up in the air monitoring one particular site, because you'd want to do that for 24/7, right? So that's mostly about the tethered drones. I don't think it's a dying market. I think it has its own unique use cases, right? Especially in both in case of police as well as in terms of border. I think people want continuous surveillance. The on-demand one, why this entire thing is actually picking up right now is because you want to go 10 kilometers from a particular place, right? And you want that information literally on demand, right? You don't care about it 5 minutes or 1 hour later, but this instant you want to know what happened, right? So that's where these kind of devices actually help, right? I hope I answered that question. I
Thank you
think
so
I'm
much,
all
sir.
over time. Thank you. Thanks everyone.
And ladies and gentlemen, that was Mugilan Thiru Ramasame. Sir, thank you so much, sir, once again. For our next session, we explore how AI is evolving beyond simple predictions to create more intuitive, immersive, and personalized retail experiences. The session will delve into the latest advancements shaping the future of retail and how AI driven insights are changing the operational efficiency. Our next speaker is Mr. Amit Kapoor. He's the Vice President of Data Analytics and AI Platforms at Lowe's, where he leads the global team driving the modernization and innovation of data and AI ecosystems. Let's welcome on stage Mr. Amit Kapoor.
Good morning, everyone. Good morning. It's a very tough act to follow when the drone session happens prior to the retail session, right? A great session. I attended half of it, but I wish them all the best. Skylark, a HR-based company. Very interesting. Maybe there might be synergies between what we do in our DCs versus what they do. So introducing myself, I've been working with Lowe's for about 11 years now. Take care of three things. One, we built our own AI platform. In the AI wave, we had our ML ops platform, and we are a build versus a buy shop. We build our own software. And you will be surprised to know we have built our own self-checkout terminal, which is right now deployed in all our 1,700 plus stores. So we are a build shop. So you will see that in the slides. I also take care of our supply chain AI. Our supply chain carries roughly around 16 to 18 billion worth of inventory at any point in time. And we are trying to optimize that through AI. Thirdly, I take care of our digital AI needs as well as stores AI needs. So those are the three functions I manage. Part of the India leadership team, and today here to talk a little bit about how we are leveraging AI in our ecosystem. So today you will see this is a practitioner's view. This is not a sales call. This is not a sales session. We're not here to sell anything, but to talk about how we are leveraging AI. And I'll also tell you, we participate in AIM every year. Last year, our team was here, and we presented a highly technical session on computer vision. We use computer vision in our stores heavily for shrink protection, for associate help, and so on. So this year we thought if we go back and if we have to share something with this group, what should it be? And we picked up a topic which is beyond the algorithm, right? I think all of us are very keen in learning the algorithm, but in our last 2 years of practicing AI, we figured out that algorithm is only so much within the entire AI journey. So we at Lowe's, we are a 83 billion world's second largest home improvement retailer. We have 1,730 plus stores, and these are large stores, mind you, right? These are like 110,000 square feet stores, and those of you who have seen it and those of you who haven't seen it, it's like Decathlon store multiplied by 6 times. Each store is that big. We have roughly around 100 plus distribution centers. 15 of those all across US, and each distribution center is roughly 1.5 million square feet. Carries almost 1,000 plus trucks at any point in time. So the scale, I'm just giving you some context so that you can understand the scale that we are talking about. We serve almost 15 million customers every week that we interface with. And from an India perspective, we are roughly around 5,000 people. Good diversity ratio. We are considered to be one of the best workplaces in India to work, where women work. 70% engineers and tech workforce. Tech is, where we started with. But now we also have around 30% of business services, which is merchandising, marketing, finance, HR, and so on. Moving on, although it's not about algorithms, but we leverage everything, right? We have 300,000 plus associates that work across our stores, supply chain, corporate offices, but we leverage everything, I'll tell you. However, I'll give you a flavor of, and we call it classic AI, right? After generative AI came in, we have started to use classic or traditional for our AI. So few examples I'll share with you, and I spoke about computer vision, that we use heavily in our stores. And I'll share with you an example, which is called a nudge. So when you go and scan something in a self-checkout terminal, which I said we built it here from our office in India, including software and hardware, nudge is something if you mis-scan a product in self-checkout terminal, or if there is a theft that is happening, we have signals through cameras where we can send a nudge back to the self-checkout terminal to ask the customer to scan that product, intentionally or unintentionally if you have missed it out. But why it is very important is that we did not want to introduce friction in between, right? You don't want to do that every time a customer misses a scan, or, if you are having your personal products, sometimes there are phones, there are dogs, you have your personal items, right? You don't want to mis-scan and send a nudge to the customer. It will introduce friction, because self-checkout terminals for us was a huge productivity gain. But AI augmented all of that and reduced shrink in a big way, right? So this is something that we have built in-house. All algorithms, including interface with the cameras, and you saw DeepStream, which is a AI interface for us from a video reception perspective. We use that a lot. I'll talk about space optimization a little bit, just to give you an idea of why do we use AI. So across our 1,700 plus stores, each store carries roughly around 40,000 products. And all those products have to be cleanly put in the shelves, rightly displayed, depth of shelf, which products to display, what is selling, what is not selling. How do you decide that? How do you price that, right? And that's where we use our space optimization algorithms to look at, do you want to optimize for sales, or do you want to optimize for margin, or for both, right? That's where we built an algorithm which looks at all the 1,700 plus stores and gives our merchants an ability to optimize either on sales or on margin, right? So we can do either, or we can do both, right? And it gives you a combination of products that you should have on your shelves, on your end caps, on your aisles, and what should be the facings of those products. So that's where we are leveraging AI. Not possible through your spreadsheets, not possible through the human eye, but AI gives you that visual and capability for you to really optimize your shop floor. Labor scheduling, like I said, 300 plus thousand associates that we have. We have seasonal flow, up and low, right? We get hurricanes when you have to probably serve the product more. How do you optimally staff your stores? When you should staff more, when you should staff low, how do you get your seasonal in? All of that is driven through AI algorithms that have been built in-house. I think this is just a flavor of, the classical AI that we have been using. But as you know, November of 2022, when OpenAI released the ChatGPT interface, everything started to change. And we, at Lowe's, as a team, also looked at what should be our AI strategy. So our AI strategy revolves around two key things, right? One is this framework that we built, which we call how we work, how we shop, and how we sell. And the second part of it is our total home strategy. So anything that we do on AI, we said we don't want to die 1,000 cuts. We don't want to die by 1,000 cuts, right? So we had a very intentional approach towards how do we build AI. And anything that we do should fall into one of these verticals, right? And to give you an example, what we did was we said first we need to focus on our customers. And for our customers, we built one of the first flagship products called Milo, which right now sits on our Lowe's.com website and serves approximately 4 million customers every day. I just have a small video to show you first, and then probably we'll go into a little bit more details.
Meet Milo, Lowe's all-new AI-powered home improvement helper. Because Lowe's knows owning a home comes with a lot of questions. And with help from Milo, we've got answers, all from the palm of your hand.
Hi, I'm Milo. I'm your home improvement helping hand.
Milo is here to help you fix it.
Milo, how do I fix my leaky faucet?
Here to help you save money.
Milo, what type of washer and dryer repair saves me the most on my utility bills?
Here to help you replace it.
Milo, show me the top-rated French door refrigerators I can get delivered and installed next day. Milo, what stain and supplies do I need to refinish an antique table?
And also, here to help you dream it.
Milo, how do I plant a raised veggie garden?
Finding answers to all your home improvement questions just got a lot easier. Meet Milo at Lowe's.com/Milo. We help, you save.
We released this interface to our customers online, but we built it once, and we are also using a version of this within our store ecosystem. So all of our 300,000 plus store associates are able to use this on their mobile devices, and we are going to activate through voice. And the reason I'm saying that is home improvement. We are a home improvement retailer, and home improvement is a tough job for our associates, because we sell in 15 broader categories, and if I'm a selling associate sitting in the store, and let's say I'm in a plumbing department, and if a customer comes in and asks me a question about which paints to use, very difficult. If you are a young college graduate who's passed out recently, for us to train that person in like 15 areas is a huge challenging job. But with this capability, with your headset, you can ask that question to the app and get an answer in the native language, and even in your earpiece, and you can help serve your customers. So that's how I think this capability is helping our associates sell with confidence in the stores. And for our customers, when you have to do something in your home, and US is a DIY, do-it-yourself market, and if you have to do some home improvement project, you have to go and search in multiple places. This solves for that, right? You can search for the ideas, you can get knowledge from Lowe's in terms of your home improvement knowledge, steps that you need to do, list of products, you can add it to the cart, and then you can buy. So this will get augmented with agentic capabilities. I know some of that is mentioned here. We have started to build those agents which will get integrated with our assistants, and then it can become an end-to-end autonomous capability for us. So that's one. Second, I think so the first two is, first one you see on website, second one you see which is in our stores, and then AI workflows. I think so a lot of times excitement is so much about AI. Everybody wants to build AI capabilities, right? And a lot of times you get requests where people are just converting rule-based things into a AI workflow and saying, yeah, we have done AI. So AI workflows, we said we use a framework, where there are 5 attributes. We say, if you're building an AI agent or an AI workflow, you should have 5 attributes. First is perception, right? Does your agent have a perception? Second is action. Is your agent able to act? Third is, goal-oriented. Your agent should really have a goal. A is autonomy. Is your agent able to take decision on its own? Last is responsiveness, right? So these 5 attributes, sometimes we call it Parag, right? We use an Indian name. Perception, autonomy, responsiveness, action, and goal-oriented. Easy to remember. So we said, if you have these, it makes sense for us to allow you to build an AI capability so that it's easier. But these are the capabilities. But then what are the learnings that, in terms of, a lot of data that you see from the industry? You will hear the news about 91% of, AI projects have failed. We are not able to deploy our agents. What's happening, right? A lot of these news that you see, a lot of this you see, in the social media, and we also receive that, right? Sometimes we also contribute towards that. But if you see on the top, on the bottom left side, we try to put some of these principles in play to make sure that we are successful. It's not that our projects did not fail, we failed, right? When we were building the first few capabilities, we had our own challenges.
we did shelf off some of our projects. But some best practices that we followed. First, I think the business sponsorship was key for us. You know, if you are building like a typical project life cycle, you see here AI project life cycle is very different than the, you know, your typical project life cycle. Milo, when we first deployed, it had an accuracy of 43%, right? Typically, if you deploy something like that, business will not accept it. That's where business sponsorship is the key. So if you're building something for your own, make sure that you have a business sponsorship. So that was a big difference for us in terms of governance structure, changing the operating model, having the business lead this shoulder to shoulder with us. Change management, I'll tell you 70% of the work from a leadership perspective that we end up doing on our projects is change management. Because when you hire an associate, and I'll use the store example, you're training associates on what they need to know. Now they need to train them on how they should interact with the customer rather than the knowledge part. Knowledge part, I think we are serving them on at will, right, when they need to know. And lastly, kill list is very important, right? Otherwise, you will end up having such a large list of things that you will get a request on, and the governance committee is extremely critical to have that kill list saying this does not align with our overall AI strategy or the corporate strategy. We do not want to build that. So what are we doing? How are we looking at what's going to happen next year, the following year, and the following year, right? We already have built some of these capabilities where our associates are able to sell with confidence, customers are able to sell with buy with confidence. So that's the first piece that we are talking about. We have also built capabilities in our contact center where, which was highly manual. They had to search for information when the customer calls. They are able to get that information real time on their fingertips, right? I don't have a video for that, but those capabilities are also live. We do have a digital twin for our store where we are able to visualize what's happening in the store. You are able to see that real time, and how can you optimize your overall store. Most of our sales come from store. That's why I'm telling you for us, stores are extremely, extremely important. One thing that we are thinking is the second bullet point on the middle one that you see, hyper-personalized customer experience. But look at the last part, conversational commerce at the forefront. I think this is one thing that we are looking at and we are experimenting with, where customers typically go browse a lot, and then they go and then you select something, add to the cart. I think slowly we feel that a shift is likely to happen where your conversational commerce will become at the forefront. When the customer starts to interact with you, you will know everything about the customer. The buying pattern, the project you're working on, what products to recommend, and the buyer decision can happen within the chat interface rather than on the site, right? And that's where agentic commerce comes in, where it will enable some of those behaviors where you don't spend time browsing, and especially with Gen Zs and all, they are changing a lot of companies how they perform, right? So in the US we are seeing those patterns where you don't go and browse the site. You just ask, I need this, buy now, and it happens. Developer productivity, I think, is a hot topic. Everybody talks about it. We have released it, across our organizations. All our developers have access. It is integrated within our ecosystem, where all our peer reviews, all our code reviews, code generation, testing, everything is started to happen, from our AI-assisted, integrated development experience. Yeah, I spoke about change management, and this is the experience I wanted to share from our perspective. We focused heavily on change management from the beginning. So at Lowe's, we built our information superhighway. We are an API company, right? So we have APIs for all of our critical products, and that's helping from an agentic perspective. When you're building your agents, underneath they need to have the data ecosystem, and that's where our data superhighway, which is our data lake, comes into existence. So we have our API layer, we have our data layer, and on top of it, we are building our agentic ecosystem. So 3 layers. I spoke about pods being sponsored by business leadership. Extremely critical. If you don't have business ownership, when you release something to business, they will say, we know this stuff, we don't need AI for this. It has changed after November of 2022. There are asks, but it's still a challenge from an adoption perspective. And that's where your leading and lagging indicators are very important.
So your leading indicators are, and that's something that we use within Lowe's, is if you build a AI product, do you have the right adoption? Do you have the right quality? Do you have the right response, right? That you will get to know the moment you release something in production. But you will not know the value because your accuracy might be only 30% on the first day. And you are going to iterate over and then increase the accuracy of that. And that's where your lagging indicators, are you impacting sales? Are you impacting experience? Are you impacting margin? Or anything else? That's your lagging indicator, right? So that's how I think we leverage it. And we told the story based on that. We did something interesting called Fail Fast Awards. We had a lot of awards and recognition within Lowe's, but within our area, people who are building on AI, we started recognizing teams who are doing meaningful work, but that's probably either organization is not ready for that, or we are not ready, or maybe the work itself is not relevant, right? So we started to recognize those teams who have put their hard work, done really, really well, but really not able to, right now the product is not viable. Training and capability, we always started with leaders first in this case, right? A lot of times your innovation sometimes can happen bottoms up or from the middle, but in this case, we ensured that at the executive leadership, there is a right sponsorship, and all the leaders are aware of, how AI is going to impact their function. Actually, there's a session that's happening later this week. Lastly, from a data governance, or adoption perspective, the KPIs which you start to measure here are extremely important for you to tell that story to business and sell what you're trying to build. So that's what I had. I can take a pause, and if there are questions, more than happy to take. We've created a virtual this thing. We are experimenting with bot also, where bot can go around for the inventory. Do you have inventory in the shelves? But we do have a digital replica where you can see the entire store in a single screen. And the live data feeds coming into that. No, that is a separate item. Those are cameras. That's cameras where those cameras can capture what's happening in the store. But if you're stealing something, you don't know whether you're going to steal it or you're going to go to the checkout terminal and take it out. You don't know. Yes, we have an algorithm called proactive replenishment. So when the stock gets over, the algorithm can tell you, go and fill the shelf. Yeah.
The guy has given the mic to other.
Yeah. Yeah. So we don't share the shift numbers, but our digital channel last quarter we reported is growing roughly in double digits as compared to the stores. So growth on the digital channel is much more than what it is growing on the store side. There could be this thing where the shift is happening, where you are eating your own numbers, but I'll also tell you home improvement journey is not very, very linear, where you start at online, finish at online. So we will start to do probably research online, then you might come into the store, go back again into online. You might do a video, call with your family to show this is what I'm buying, and then probably the sale happens. So we capture omni sales actually. Customers who are our loyalty customers, and then who shop, either online or stores, they probably shop much more than who are not connected to our loyalty. So that's how we measure our sales.
You capture the phone number and all that. Yeah. And when is your agentic AI coming into picture? When will it roll out finally?
So for one of the areas we have rolled out where you can place an order end to end. It is a Lowe's Pro services where we have rolled out an agent through chat. You can just place your order directly there. On the Milo, I think it is yet to be deployed on Milo.
Okay. And there's no human intervention in that?
No human intervention.
Okay, thank you.
Yeah.
Hi, sir.
Thank you so much.
First of all, thank you for this wonderful presentation. Yesterday, while we were listening to multiple speeches, one thing that we got to know is voice is the next big thing, right? And mixing with AI, voice-enabled AI is something that is the next big thing.
Yeah.
So what do you think? How are you guys planning to integrate voice into your platform?
So I spoke about Milo Companion, which sits in a store. Actually, I think this month or next month, we are going to enable all of that through voice. Because for our associates who are working in the store, if they start typing, they lose the touch with the customer, right? So we're going to enable that through voice where they can get a question through to the voice and also hear it back through voice. And also we are multilingual, right? We serve Spanish customers and other customers, so this will enable multilinguality also.
Got it. And one more question, right? From a business standpoint, if I look at the model of DMart, the placements are in such a way that it enables customer to buy. For example, a chocolate is on the rack. It might not be in my mindset, but I would like to buy because I saw it, right? And similarly, in your workspace, let's say there is a cool, I would say, washer or a cool tab that feels attractive to me. So do you think there would be a shift in the buying pattern or buying behavior if you are bringing in just to ask and then they are redirected to the direct warehouse or direct place?
Great question. We do that, right? So we do that from multiple angles. One, if you're working on a project, let's say you're doing your bath refresh, so we make sure that those are co-located. And we also look at adjacencies, which products will go together. And all that is taken into account in the space optimization to make sure that those products can be co-located and it's easier for customer to pick those up.
Right. Thank you.
Thank you so much, gentlemen. One last question from you.
Hi, Amit. My name is Charan. So retail is a very vast and distributed space, like the different players, third party, etc., etc. So with the model that you showed in here, how Laos work, sell, and operate. Shop, sorry. Yeah. How do you extend the same model with the other players in the retail space? Somebody like warehouse management players, transportation, shippers, etc. Because to achieve a seamless experience, it quite has some impact and dependency.
Yeah. I think for us, this one framework fits really, really well from our total home strategy. We are able to serve our customers. We are able to serve our associates who are actually doing selling. And then third, our associates who are serving all of those, right? So this framework works for us, I think, for transportation, for warehouse. They can also leverage some of this, I feel, right? Because end of the day, any company will have their customers and how you're serving them is very important. Like us, I think for everyone, customer sits right in the middle, right? So how we shop is for the customers, how customers interact with you, what are the interfaces. How you work is for your internal associates. And maybe if you need to have a third one, you can add a third one to that. So I think framework can be adopted. This allowed us to make sure that we have a structured way of approving our AI workflows.
Yeah, thank you. Handshaking with the others.
Thank you so much, Mr. Amit Kapoor. Ladies and gentlemen, we will be having Honorable Priyank M. Kharge, Cabinet Minister, Electronics, IT, BT, and Rural Development, Panchayat Raj at Government of India tomorrow. And he will be talking on Karnataka's Tech Vision AI startups and innovation hubs. So make sure that you do not miss his lecture tomorrow, as it's going to be very important. We're going to meet back at please come back by 12:35 as we'll be starting our next session by 12:40. I'll see you soon.
health, their nutrition, their cravings, their habits. They care about what's familiar and what's exciting, about eating right and eating well, about celebration and routine, comfort and discovery, taste and trust, all at once. And when customers care this much, so should we. We have already made it easier than ever for customers to get the food they want, when and how they want it. Convenient, fast, efficient, undeniably powerful. But now, it's time to move beyond convenience and bring soul into every experience. And that's why our vision is to build technology that cares for the customer, with intelligence that adapts, with rewards that delight, with systems that move fast but always feel thoughtful. Because food is personal, and so should be the experience around it. With our thoughtfulness, we are engineered to deliver value at every level. At SmartQ, we're not just building for what's now, we're building for what matters next. SmartQ, built for the customer, built for experience, built for what's next.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Milky Way is an agentic decision intelligence system that facilitates open-ended multi-turn questions by transforming raw enterprise data into key decision points along with recommendations and dynamic reports, with 5x speed and 50% lower cost. Imagine you're an e-commerce analyst looking for quick insights. Ask Milky Way, what are the top 10 performing product categories in terms of sales growth? Milky Way instantly gives you the quick insights you need to understand performance. But what about deeper, diagnostic questions? Say you're a sales director, and Midwest sales are down 15%. You ask, why did sales decline last quarter? Milky Way responds like a seasoned analyst, asking clarifying questions, just like human-led deep research. Milky Way uses expert traces from Trident's retail, CPG, TMT, banking, travel and hospitality, etc. use cases to generate tailored hypotheses, fully editable by the user. ReasonX powers deep analysis, leveraging client-specific ontologies, a growing hypotheses bank, and robust evaluation frameworks. Milky Way performs data quality checks, sufficiency tests, and rigorous eval-based hypothesis validation. It instantly extracts relevant data for each hypothesis and runs deep analysis at scale. Post-analysis, it generates a transparent, comprehensive report, ready to edit, download, or share. But it doesn't stop there. Milky Way helps you uncover better questions, explore new angles, and builds context over time, learning from past interactions to personalize every session. Unlike traditional GenAI tools, Milky Way isn't prompt-bound. It is a constellation of domain-specific intelligent agents, orchestrated to solve real business problems in real time.
Artificial intelligence, AI, coexisting. AI.
We are AIM Media House. Born in Nama, Bengaluru. Built for the world. We make tech make sense. We tell stories that matter. This is the era of AI, and we are the ones telling its story. Think AI, think AIM.
I have seen this place grow from strength to strength. Speakers, the sessions, and the vibe around that.
Love the vibe. Love to see how big it has gotten over the years.
The largest AI conference in India.
Cypher has definitely attained a cult status.
In the age of intelligence, life sciences need more than just data. To make smarter, faster, and more personalized decisions with AI agents powered by InsightsMax.ai. From drug discovery to commercialization, from brand launch to loss of exclusivity, our solutions span the entire product lifecycle. We meet you where you are in your AI journey. Exploration, experimentation, commercialization, adoption, and maintenance. Whether you're building early prototypes or scaling enterprise-ready AI agents, Axtria helps you move with purpose. With InsightsMax.ai powered bespoke AI agents, Axtria accelerates the path from insight to decisions to action and outcomes. It's not just AI, it's better outcomes for patients, It's faster, more confident decisions for life sciences to better people's quality of life. It's real change, delivered at scale. With deep domain life sciences expertise and a global presence, we partner with the world's leading organizations to shape a healthier, more intelligent future. We're Axtria. AI first. Life sciences focused. We turn innovation into transformation. Join the journey. www.axtria.com.
India's digital future deserves more than imported infrastructure. It needs a cloud that's built here, governed here, and always under your control. At NextGen, we don't just deliver cloud, we architect sovereignty, intelligence, and performance into every solution. Whether you're a government body navigating compliance, a bank juggling audits, or a startup scaling AI models, NextGen gives you the platform, performance, and partnership you need to lead. Our portfolio is unmatched. Speed Cloud, our public cloud, delivers industry-leading performance and savings of
checkup.
This is an AI system that's going to be listening to us and it's going to be scribing the notes.
Right on his phone, Dr. Robin Baradarian is running a high-tech tool called Suki AI.
Any family history of any problems?
While he talks with patient Michelle Barone in an exam,
I feel burning up. Sometimes I even feel it in my ears.
Suki takes notes, letting the doctor focus.
India's digital future deserves more than imported infrastructure. It needs a cloud that's built here, governed here, and always under your control. At NextGen, we don't just deliver cloud, We architect sovereignty, intelligence, and performance into every solution. Whether you're a government body navigating compliance, a bank juggling audits, or a startup scaling AI models, NextGen gives you the platform, performance, and partnership you need to lead. Our portfolio is unmatched. Speed Cloud, our public cloud, delivers industry-leading performance and savings of up to 80% versus global providers. Backed by OpenStack, RDMA, and blazing NVMe Stream is your next-generation private cloud, on-premises or hosted. Built on Red Hat OpenShift, it gives you 24/7 fully managed operations, transparent pricing, and the ability to move from VMs to AI applications seamlessly. Financial Services Cloud is made for India's BFSI sector. 100% compliant, 100% Indian data residency, and immune to foreign laws. It's where trust meets technology, helping banks and insurers innovate without risk. Government Community Cloud is certified for India's unique needs, supporting everything from election analytics to critical public workloads. Mission critical, always on, and fully aligned with Digital India and self-reliance. Our AI-ready infrastructure is built from the ground up for scale and speed, delivering NVIDIA, AMD, and Intel GPUs on demand. Whether you're training large language models or deploying AI-powered citizen services, we enable your journey from provisioning to meaningful, real-world use cases. With our patented SaaS framework, you get a full-stack AI platform, from solution engineering to deployment to continuous improvement. Plug-and-play AI SaaS, custom model hosting, or scalable inferencing. Just pick what you need. Security isn't an add-on, it's at the core. India's digital future deserves more than imported infrastructure. It needs a cloud that's built here, governed here, and always under your control. At NextGen, we don't just deliver cloud, we architect sovereignty, intelligence, and performance into every solution. Whether you're a government body navigating compliance, a bank juggling audits, or a startup scaling AI models, NextGen gives you the platform, performance, and partnership you need to lead. Our portfolio is unmatched. Speed Cloud, our public cloud, delivers industry-leading performance and savings of up to 80% versus global providers. Backed by OpenStack, RDMA, and blazing NVMe storage, it outpaces AWS, Azure, and Google Cloud in real-world benchmarks. Speed Cloud Supreme is your next-generation private cloud, on-premises or hosted. Built on Red Hat OpenShift, it gives you 24/7 fully managed operations, transparent pricing, and the ability to move from VMs to AI applications seamlessly. Financial Services Cloud is made for India's BFSI sector. 100% compliant, 100% Indian data residency, and immune to foreign laws. It's where trust meets technology, helping banks and insurers innovate without risk. Government Community Cloud is certified for India's unique needs, supporting everything from election analytics to critical public workloads. Mission critical, always on, and fully aligned with Digital India and self-reliance. Our AI-ready infrastructure is built from the ground up for scale and speed, delivering NVIDIA, AMD, and Intel GPUs on demand. Whether you're training large language models or deploying AI-powered citizen services, we enable your journey from provisioning to meaningful, real-world use cases. With our patented SaaS framework, you get a full-stack AI platform, from solution engineering to deployment to continuous improvement. Plug-and-play AI SaaS, custom model hosting, or scalable inferencing. Just pick what you need. Security isn't an add-on, it's at the core. NextGen delivers defense-in-depth, AI-driven threat intelligence and full compliance with Indian regulations. With 99.95% telemetry, logs, and full access at every layer. This is cloud on your terms, modular, open, and always sovereign. With NextGen, you're not just choosing a vendor, you're gaining a partner dedicated to India's digital destiny.
future looks like wow. Oh wow. It's like wow. Yeah, future looks like wow.
Once upon a time in the narrow streets of London.
It's like wow. Future looks like. Future looks like wow. And it starts right now. It's like wow.
Hey, can I check the status of my order?
Yes, of course. Your order is due to arrive at around 2 p.m.
Oh wow. And it starts right now. Future looks like wow. Oh wow. And it starts right now.
Let us bring humankind together as one.
Future looks like wow. Oh wow. And it starts right now. Yeah. Future looks like oh wow.
EPAM India, one of the fastest growing advanced technology companies in the region. A modern engineering partner to more than 175 global clients across industries, helping them accelerate at scale and advance on the technology curve, one innovation at a time. We are located at Hyderabad, Bangalore, Chennai, Gurgaon, Pune, and expanding to new cities. With key capabilities around AI, digital, cloud, data, analytics, open source, and quality engineering. We built our culture around engineering excellence and drive it through our communities. We encourage our people to speak up and have a product mindset. EPAM India has been recognized as Best Workplace, GPTW, Best Company for Women by Avtar, Best Leadership Development Program for Middle Management. Outstanding contribution to AI skill development. We drive AI enablement differently, with more than 90% AI skilled associates and roles like Advanced AI Solution Developer. Our social responsibility and sustainability efforts, EPAM India contributes to Trees for Tomorrow program and supports Wild Wisdom Global Challenge, WWF, and help improve environmental literacy. We provide access to high-quality technology education for 15,000 plus students from government schools through eKids Digital Labs. We are the home of modern Indian engineer.
Customers care. They care about their health, their nutrition, their cravings, their habits. They care about what's familiar and what's exciting. About eating right and eating well. About celebration and routine, comfort and discovery, taste and trust, all at once. And when customers care this much, so should we. We have already made it easier than ever for customers to get the food they want, when and how they want it. Convenient, fast, efficient, undeniably powerful. But now, it's time to move beyond convenience and bring soul into every experience. And that's why our vision is to build technology that cares for the customer, with intelligence that adapts, with rewards that delight, with systems that move fast but always feel thoughtful. Because food is personal, and so should be the experience around it. With our thoughtfulness, we are engineered to deliver value at every level. At SmartQ, we're not just building for what's now, we're building for what matters next. SmartQ, built for the customer, built for experience, built for what's next.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Milky Way is an agentic decision intelligence system that facilitates open-ended multi-turn questions by transforming raw enterprise data into key decision points along with recommendations and dynamic reports, with 5x speed and 50% lower cost. Imagine you're an e-commerce analyst looking for quick insights. Ask Milky Way, what are the top 10 performing product categories in terms of sales growth? Milky Way instantly gives you the quick insights you need to understand performance. But what about deeper, diagnostic questions? Say you're a sales director, and Midwest sales are down 15%. You ask, why did sales decline last quarter? Milky Way responds like a seasoned analyst, asking clarifying questions, just like human-led deep research. Milky Way uses expert traces from Trident's retail, CPG, TMT, banking, travel and hospitality, etc. use cases to generate tailored hypotheses, fully editable by the user. ReasonX powers deep analysis, leveraging client-specific ontologies, a growing hypotheses bank, and robust evaluation frameworks. Milky Way performs data quality checks, sufficiency tests, and rigorous eval-based hypothesis validation. It instantly extracts relevant data for each hypothesis and runs deep analysis at scale. Post-analysis, it generates a transparent, comprehensive report, ready to edit, download, or share. But it doesn't stop there. Milky Way helps you uncover better questions, explore new angles, and builds context over time, learning from past interactions to personalize every session. Unlike traditional GenAI tools, Milky Way isn't prompt-bound. It is a constellation of domain-specific intelligent agents, orchestrated to solve real business problems in real time.
Artificial intelligence, AI, coexisting. AI.
We are AIM Media House. Born in Nama, Bengaluru. Built for the world. We make tech make sense. We tell stories that matter. This is the era of AI, and we are the ones telling its story. Think AI, think AIM.
And I've seen this place grow from strength to strength. Speakers, the sessions, and the vibe around that.
Love the vibe. Love to see how big it has gotten over the years.
The largest AI conference in India.
Cypher has definitely attained a cult status.
In the age of intelligence, life sciences need more than just data. They power of AI to make smarter, faster, and more personalized decisions with AI agents powered by InsightsMax.ai. From drug discovery to commercialization, from brand launch to loss of exclusivity, our solutions span the entire product lifecycle. We meet you where you are in your AI journey. Exploration, experimentation, commercialization, adoption, and maintenance. Whether you're building early prototypes or scaling enterprise-ready AI agents, Axtria helps you move with purpose. With InsightsMax.ai powered bespoke AI agents, Axtria accelerates the path from insight to decisions to action and outcomes. It's not just AI, it's better outcomes for patients, It's faster, more confident decisions for life sciences to better people's quality of life. It's real change, delivered at scale. With deep domain life sciences expertise and a global presence, we partner with the world's leading organizations to shape a healthier, more intelligent future. We're Axtria. AI first. Life sciences focused. We turn innovation into transformation. Join the journey. www.axtria.com.
India's digital future and always under your control. At NextGen, we don't just deliver cloud, we architect sovereignty, intelligence, and performance into every solution. Whether you're a government body navigating compliance, a bank juggling audits, or a startup scaling AI models, NextGen gives you the platform, performance, and partnership you need to lead. Our portfolio is unmatched. Speed Cloud, our public cloud, delivers industry-leading performance and savings of up to 80% versus global providers. Backed by OpenStack, RDMA, and blazing NVMe storage, it outpaces AWS, Azure, and Google Cloud in real-world benchmarks. Speed Cloud Supreme is your next-generation private cloud, on-premises or hosted. Built on Red Hat OpenShift, it gives you 24/7 fully managed operations, transparent pricing, and the ability to move from VMs to AI applications seamlessly. Financial Services Cloud is made for India's BFSI sector. 100% compliant, 100% Indian data residency, and immune to foreign laws. It's where trust meets technology, helping banks and insurers innovate without risk. Government Community Cloud is certified for India's unique needs, supporting everything from election analytics to critical public workloads. Mission critical, always on, and fully aligned with Digital India and self-reliance. Our AI-ready infrastructure is built from the ground up for scale and speed, delivering NVIDIA, AMD, and Intel GPUs on demand. Whether you're training large language models or deploying AI-powered citizen services, we enable your journey from provisioning to meaningful, real-world use cases. With our patented SaaS framework, you get a full-stack AI platform, from solution engineering to deployment to continuous improvement. Plug-and-play AI SaaS, custom model hosting, or scalable inferencing. Just pick what you need. Security isn't an add-on, it's at the core. NextGen delivers defense-in-depth, AI-driven threat intelligence and full compliance with Indian regulations. With 99.95% uptime, disaster recovery options, and geo-redundancy, your workloads stay safe, compliant, and always on. And unlike black box clouds, you get true visibility, telemetry, logs, and full access at every layer. This is cloud on your terms, modular, open, and always sovereign. With NextGen, you're not just choosing a vendor, you're gaining a partner dedicated to India's digital destiny.
check. Rise and shine, everyone. Good afternoon. Welcome back. You've had your lunch, guys? Respected audience, you've not had your lunch? Well, I've had my lunch, so I'm going to pass my energy towards you. So that until your lunchtime comes, you can be fully rejuvenated. Ladies and gentlemen, I have a very important information to give. Tomorrow we will be having our Honorable Priyank M. Kharge. He's a cabinet minister in electronics, IT, BT and rural development Panchayat Raj at Government of Karnataka. And he will be talking on Karnataka's tech vision, AI startups and innovation hubs. So do make sure that you attend it because this is coming from the OG, which is originally from one of our very important leaders. And it's going to be a very important session. All right, ladies and gentlemen. Excuse me. In our next session, we have the author of Designing Human-Centric AI Experiences, who will explore how natural interactions and ambient intelligence and reshaping our relationship with technology happens. He will share practical principles for designing interfaces that feel natural and almost invisible, where the technology fades into the background and feels like magic. Our next speaker is Mr. Akshay Kore, Senior Designer Manager at Suki, and he is also an author, has worked with Microsoft's AI research group and observe AI before leading design at Suki, AI mentoring a team focused on simplifying clinicians' lives through AI. Well, ladies and gentlemen, you know it better than me. Let's welcome on stage Akshay Kore!
Hello? Hello? Is it better? Awesome. Thank you. So, I hope some of you have had your lunch and are feeling energetic. I know this is a post-lunch session, so you're having your, probably some of you are drowsy already. But I'll try to make it as entertaining as possible. So I want to start with a bit of a story. So at home, when I was growing up, my mom had two of the best speech recognition systems. They would understand everything that she said. They would sometimes even act on behalf of her. They could do simple tasks like switching on the light, changing the channel on the television, as well as complex things like deciphering handwritten notes to buy specific things from specific shops. And they could also, like if something was not available at a specific shop, they would go to another shop. They could also negotiate sometimes. They could understand her tone of voice. When she said, turn it off, it meant that we had to lower the volume on the TV. These advanced speech recognition systems could do much more by gaining new skills. One of them learned how to design products, another learned history. All this didn't last for too long because for in a few years, my sister and I moved out to the house. Hello, my name is Akshay Kore. I'm a product and design leader at Suki, and I'm an author of a book called Designing Human-Centric AI Experiences. Studied at IIT Bombay, where I worked on GIS systems and a lot of recommendation systems. Post that, I also studied at ISB, where I worked on a project on introducing technology into millet farming. I started my career at Microsoft, where I worked with their AI research group, primarily on personal assistants. Some of you may have heard of Cortana. This was very early days of voice assistants. After Microsoft, I worked at this startup called Observe.ai. Observe.ai works in the area of automating contact center conversations and evaluations. And here I worked on an interesting product called AutoQA. The goal of AutoQA is to, every contact center gets millions of conversations every day. And the goal of a contact center is to manage the quality of these conversations. AutoQA essentially allows a contact center to build ML models easily in a sort of a DIY fashion, and you can sort of evaluate your conversation and say if whether a conversation went well or not. Things like CSAT, etc., is measured through that. I currently work at this company called Suki.ai. At Suki, what we're doing is we're designing AI assistant for clinicians. As you can see, there is a little bit of a pattern in my work. What I'm most known for is this book called Designing Human-Centric AI Experiences. It's also won an award called the Best Artificial Intelligence Design Book of all time. It's a popular textbook. It's been used in lots of universities like IIT Bombay, Bangalore, Stanford, MIT, as well as large big tech like Microsoft, Amazon, Meta, Google, Tesla, etc. So your usual suspects. I love talking about this topic. I also teach a course on designing AI products at IIT Bombay and at IIM Bangalore. So before you head in, I want to set some context. So the people who invented electricity did not know that we would get things like gaming consoles or microwaves. Something similar is happening with AI, right? We right now have this fundamental technology, but we don't know what the microwave of an AI looks like, or we don't know what a gaming console of an AI looks like. So I will start by saying that I don't know what I'm saying. No one knows the future, and we are all trying to figure it out. So take whatever I say with a pinch of salt. While we do this, we are just discovering. I just happen to have designed lots of AI products. One detail, I wrote my book before ChatGPT was released, so I've been working in this field for quite some time, and it was very lucky and also happenstance that like things panned out the way they were, and which is why I am here on this stage. Again, no one knows the future. We're all trying to figure it out. Today I wanted to share two ideas with you, and these ideas will help you think about AI differently and also help you design better AI products. Right? First is nobody wants to use a product. And the second is you don't really want to chat with your AI. Okay. No one wants to so for the first idea is no one wants to use your product. They just want to get something done. Okay. You don't want to use a clock app. You want to wake up on time. Right? You don't want to use PowerPoint. You want to communicate your idea, right? If you're designers in the room, you don't really want to use Figma. You want to create a beautiful interface. So the idea is that the scare is whether it solves the problem or not, which is what they're paying you for. The second idea I want to share is you don't really want to chat with your AI. You want to communicate with it, right? What comes to mind when I say AI interface right now? examples of like real world products. For example, like Teenage Engineering is a firm that builds interesting hardware products. It's this recorder that you see is called TP7, and it's an AI-enabled recorder. Essentially, it enables somebody to record music or record their voice and sort of transcribe, summarize, do interesting things with that interface. But the interface for this specific recorder is very tactile, handheld. Does not feel like a phone, or it does not feel like you're touching glass all the time. And the advantage of this is most of the people that use this recorder swear by it, and it's a very expensive device. Despite that, like a lot of people just buy it because it's nice and it is easy to use, and it's like very interesting also. This is the same company that builds Nothing phones. So Nothing phones also have interesting designs. Same company that designs this. You have things like this, the yellow ball that you see. That's an ambient orb. So it's an orb that you can program to track anything. And a lot of finance folks use this in certain industries, where like you can track the price of a stock or price of the status of the market based on this orb, and it tells you this information ambiently. You don't need to look at a ticker. You don't have to look at this information. Like if it is green, it's fine. If it is red, I need to do something about it. Most of the times it is somewhere in the middle, and you don't really need to do anything about it. There's this product called the Rolly Seaboard. Again, a very popular interface in the music domain, where this is an evolution, or they're calling it as an evolution of the keyboard, but then unlike a keyboard where you sort of tap a button, or unlike a sort of an iPad-based music device where you tap on different like places in the screen, this one allows you to do more interesting things like press, hold, swipe, and doing these actions would sort of generate different kinds of sounds, essentially. And it allows you to build a lot of interesting music. Very big producers like A.R. Rahman, Hans Zimmer, these guys also use this. So the point being that you don't have to always chat with your AI, right? There is different ways of interacting with AI. You can chat with your AI, you can tap with it, speak, look, interject, sniff, hold, suggest, etc. Right? And sometimes it is going to be easier to use AI and use chat and some of these interfaces. Again, I have nothing against chat interfaces. They make sense in certain contexts. But other times you want to speak. Other times you want to just point to something, right? Oftentimes you may not even want to interact with your AI. Right? Sometimes it's better that the AI itself is proactively telling you things. And sometimes it is better if the AI understands me. So to summarize, we spoke about two ideas. One, no one wants to use a product. They just want to get something done. You don't really want to chat with your AI. You want to communicate with it. That's my time. Thank you.
Ladies and gentlemen, if you have any questions related to the session, please go ahead.
Hi, I have a question here. So how do you see the privacy angle to this? You're collecting data from non-conventional methods, right? In addition to chats. So how do you see the privacy aspect there?
Can you elaborate on?
Like, if my voice is being captured, or my behavior is captured, the touch of a keypad is captured, it's kind of my biometrics, if you think of it in that way. So how do you see that?
I feel a lot of it is like the idea of this being, it is not about these interfaces or devices capturing information on some sort of a cloud server. A lot of this can also be on device, right? Like privacy is taken care of on device. You're using biometrics to largely verify if that person is authentic or not, and not anybody else is getting into it. But yeah, there's like the topic is far more complex for me to answer in like just this. Well, but the idea being there is like lots of techniques to control privacy. There's laws, regulation, as well as like things, decisions, engineering decisions that you can make to build things on device as much as possible.
I'm with you there. Just one, this question might come up every time, we present it to somebody. So thank you for answering.
Hi, this side.
Hi.
Yeah, really interesting presentation and quite relatable for me because I have been also figuring out few of these things. My question is, with your experience at Suki or Observe AI, how were you able to actually implement some of these ideas? Because some of the inspirations that you shared were mostly around like some other type of devices, etc. But particularly in some of the apps that we are building on day to day, maybe Observe AI inspiration would be more relatable to me particularly. So yeah.
So the question being, how are we sort of incorporating these? So
implementation.
It starts with like thinking beyond like chat and what is the traditional way of doing things, and like thinking deeply about what is your user even trying to do. Essentially, if they're trying to, for example, if they're trying to take a picture of something, right, you would not really have a chat interface there. You would just have a button in that case. So it will also depend on the context of what your product is and what you're trying to solve. And a good way to detect this is also observe your users and see what is the regular pattern that they do in their daily life. For example, like if somebody is doing a lot of keyboard clicks, maybe chat is okay for them. But if somebody is using a lot of pen and pencil or pen and paper, etc., do things, there is a inkling of an interface idea that is there when you do that thing. So do you want to enable a stylus-based interaction or not? Something you might be able to determine based on your user. Again, every user is different. For example, if you're designing for coders, keyboard chat is a decent interaction. But if you're designing for like somebody who's a very busy executive and like they do most of their tasks through voice. In our case, like for example, at Suki, right, we work with a lot of doctors in the US. For doctors in the US, it is surprising that most of them use their voice a lot more than they use their keyboard. So most of their tasks on the EHR are largely done through like some sort of a microphone or a voice. So for them, like voice is a much more natural interaction because they come from that world of having these human assistants as to like sort of transcribe things for them. They used to have a scribe, etc. So that is a natural transition for them to move to technology. And the good thing is that we have gotten to a point with LLMs and like in general like AI technology where like a lot of these things become possible for us to build. So feasibility often is not really the question. How you design it becomes the question then.
Thank you.
Yep.
Hi, this side. My name is Manish Rajoria. We run a trust hospital in India. So this technology is being used in the US and they are making good optimum use of it. In India, the case scenario is a little different. So one is the multiple languages we have in our country. And second, to an extent, the ethical practices of the doctors. So do you have plans of doing something in India, or we could partner and do some pilots here?
I can connect you with somebody from my team and they can take it forward.
Currently, nothing's happening in
Nothing
the
in
country.
Hi. I'm Aditya from Fidelity. So I had a question regarding the transcribing that you are doing in Suki, right? So currently the models usually just transcribe the text and it's just the text, right? But are you seeing any scope of, or are you researching on transcribing the emotions as well of the voice, the pitch, maybe it rises or it falls down, and anger, or if the patient is experiencing or talking something in an emotional way. So is that getting transcribed as well somehow?
So not at the moment at Suki, but like in my previous work at Observe, that was one of the areas that we really looked at, because call center conversations are often heated,
right?
And like you are only calling a call center if you have a problem with something. You're not really calling if you're happy with something. So analyzing the emotion of a call, going from like it being a heated call to a not slightly heated call is also a signal for a better CSAT over time. So, like emotion, intonation of voice, it's called also prosody, etc. That's used to sort of determine, like, in some ways, quality of your conversation, and that you can have a little bit of correlation between the quality of your conversation and the actual CSAT or NPS that you get. For example, you want to map, or you also want to, as a company executive, you also want to map whether a 5-star rating means good, extremely good, or like not good, and they were just forced to give you a 5-star rating. Because at the end, like, the actual quality of the conversation matters, while the incentives for like a call center executive then are to sort of get the most ratings, because their like compensation sort of depends on that. So you want to like have a balance of that. So yeah, we use like techniques like this to build out like these models.
Thank you. Thank you.
Hi, my name is Prithvi and I'm from Dun & Bradstreet.
Hi, Prithvi.
So besides the chat interfaces, so which is the most common interface, and which do you think is the most unexplored, harder to build, and which has a lot of future interface?
So in my research, I feel like, and I've been working in voice interfaces for a long time. Like I've been bullish on voice interfaces since 2010-ish. And also like our work at Cortana was like also a lot of early voice interfaces that we were trying to build. The technology was not there yet, but now I think the tech is there. You have things like 11 Labs, etc., where they're doing very cool things with voice itself. So I think voice is still continues to be unexplored, but the challenge is it has to be nuanced. Like voice doesn't make sense in all contexts. For example, if I'm in a busy environment, your voice interface is not going to work. But if I'm in like a private environment, their voice seems to work. If I'm in like, the term is like temporarily handicapped. It's not a good term, but the idea being like, when I'm driving a car, I can't do anything else. So that time voice might be good. If I'm performing surgery and I want some information, I cannot open my phone and tap on a bunch of things. So I might want to use voice at that point. So for me, like voice is the next, seems to be still be unexplored.
Okay.
You have like Alexa and like devices like this, but like adoption is like mixed at this point.
Yes.
It's not something you interact with daily, or like some people interact with it daily, but like I don't think it's like a common interface. Apart from that, like your augmented reality, mixed reality is probably also going to be interesting, but I think that's still far. We are yet to see like real big applications of it.
Okay, thank you.
Hi.
Hi.
Just one question. Hi, my name is Atharva.
Hi, Atharva.
And I really like how you started the presentation by saying users don't really care about your AI frameworks. They want to get something done. So using the same example that you showcased of the doctors, how you're enabling experts and specialists to do their jobs without having to focus on the technology that is present to, sort of aid them. So in a situation like that, how do you test a product with these end users, and how do you ensure, how do you measure the trust and comfort of such end users in a way that the AI is not really obstructing their day-to-day and their responsibilities, but is there as a background sort of an assistant?
One of our goals is also to have technology get out of the way of the user. Like we want them to be able to do their job in the best way possible, without really having to think about how to use a piece of technology, essentially. The way to measure it is largely by just talking to as many users as you can, observing them in their environment preferably. And then of course you continue to get feedback. So again, like I said in the beginning, we are all trying to figure it out, so I don't have a good answer for you. But the idea being like you just observe and learn from talking to your users.
Thank you.
Yes. Someone else?
Hi, can you hear me? Yeah. Here, right at the back.
Hi.
Hi. So one thing which I really liked what you showed was the Star Trek thing. I mean, as a kid, I've been inspired by that as well. I'm looking for a more futuristic thought from you in terms of technologies like Neuralink, which is working on machine-to-human interface. with that in mind, what do you see the future of this type of, a typical UI or a UX? How is it going to be in the future?
Yeah, so the idea of like my slide on like interfaces being invisible, right? That was the idea. You like eventually it feels like you're not going to be interacting with tech as much, because tech is largely a medium to get something done. Right? So
How far in the future you think it's going?
Like don't
I don't know.
I don't want to make predictions.
Yeah, hi. This side. Yeah. On your left. Yeah, hi. This is Vikram from Vedifix. Like we are working on a scribe product for Indian doctors, like somebody asked here. Very much similar to what Suki AI does, but definitely with specific models being trained on Indian data sets. So to give more relevant note creation and application. Very interesting thing about devices is, like if you see some competitors like Suno AI, my specific question is related to the speaker identification. Like in Suno AI, what we see is they identify the speaker at a hardware level. They give like specific mics, whereas product like Suki does on phone. So how do you do a very good job at speaker identification at Suki?
Yeah, it's largely based on like diarization models, etc., that would sort of help you to the speaker identification. And again, like your phone microphones are quite good now, so you don't really need additional hardware for these things to work well. Of course, like specific mics and stuff like that might help, but your phone microphone, your iPhone microphone especially, is extremely good at capturing voice. So we largely use like models on top of like the voice data to sort of do the diarization.
Okay.
So, I think Suno is probably doing it at the hardware levels.
Yes. So it doesn't mix up like to the direction. They have working pretty well for Suki, is what you mean?
Yes. In fact, like a lot of companies, like Google does it, Meta does it. Like it's a pretty old problem, actually.
Okay.
So it's like pretty decently solved for a lot of use cases. Again, like you can always improve these things, but I think it works for like in a lot of cases.
Yeah, thank you.
One last question, ladies and gentlemen. Please go ahead. Anyone else? Do you have any questions, ladies and gentlemen? No? Can we please pass the mic towards him?
Yeah, thank you. So I might be wrong, but I just have a question, right? So what is the difference between DeepGram, what that is doing, and what you are doing, right? So it's basically speech to text, right?
Yeah.
So. Yeah.
Got it. So I don't know what DeepGram does anymore, but like when last time I checked, they were largely working on transcription of like voice data. What we do is like along with transcription, like a true transcript is not useful. Essentially, you need to do a lot of work on top of the transcript to extract the right kind of information, the right kind of document, and different kinds of artifacts that are needed for different use cases. Not just in medicine, even if you take law or something, right? Your true transcript of a court trial is not useful because it's going to have a lot of raw data, but you're not going to be able to extract any insights out of it. What might be useful if it generates a report out of it. It tells me these places are points of interest for me, etc. So we basically operate at that level where we sort of are extracting insights and doing interesting things with transcription. But transcription like is fairly trivial at this point. So.
Thank you very much, sir.
Awesome. If there's no other questions, I will see you guys outside. Thank you, everyone.
Thank you very much, sir, for this very enlightening session. Now, ladies and gentlemen, let me tell you that we're going to have Honorable Priyank M. Kharge, our Cabinet Minister of Electronics, IT, BT and Rural Development, Panchayat Raj at Government of Karnataka, tomorrow with ourselves, and he's going to be talking on the topic of Karnataka's tech vision, AI, startups and innovation hubs. Well, before he comes here tomorrow, he has sent a message for all the people who are attending. So here is his message. Here we go. Well, ladies and gentlemen, more of an introduction, less of a message. But if you know about him, you must know what personality he is and the information that you will be enchanted with tomorrow. I have a great news for you all that into GenAI, AI or data science, stall 11 is where the future is happening. So you can go and check out the stall EXL. All things AI, analytics and data science. Yep, it's all buzzing at EXL, stall number 11. Whenever you get the time, please go there and check it out because it's a vibe that you do not want to miss and you can become a part of the tribe. And I kind of believe that, you know, such opportunities and such magnificent brands only come together once in a while. So do make sure that you go and check all the stalls, not just EXL, but this is going to be very fantastic. So do not miss it. Ladies and gentlemen, Cypher 2025 is the 9th edition, and we've been doing a great job of bringing all the AI technologies together and profoundly presenting it to all our audiences. It is only because we have such great sponsors and such great audience. And I kind of believe that, you know, it is a very important thing to mention who our sponsors are. So here are the videos. Please do go ahead and watch it before we start the next session. All right, ladies and gentlemen, before the video starts.
In the age of intelligence, life sciences need more than just data. They need decisions powered by AI. They need Axtria. At Axtria, we help life sciences companies harness the full power of AI to make smarter, faster, and more personalized decisions with AI agents powered by InsightsMax.ai. From drug discovery to commercialization, from brand launch to loss of exclusivity, our solutions span the entire product lifecycle. We meet you where you are in your AI journey: exploration, experimentation, commercialization, adoption, and maintenance. Whether you're building early prototypes or scaling enterprise-ready AI agents, Axtria helps you move with purpose. With InsightsMax.ai powered bespoke AI agents, Axtria accelerates the path from insight to decisions to action and outcomes. It's not just AI. It's better outcomes for patients. It's faster, more confident decisions for life sciences to better people's quality of life. It's real change delivered at scale. With deep domain life sciences expertise and a global presence, we partner with the world's leading organizations to shape a healthier, more intelligent future. We're Axtria, AI first, life sciences focused. We turn innovation into transformation. Join the journey. www.axtria.com.
Ladies and gentlemen, this announcement is about the panel discussion, which has actually started at 1:15, and this discussion will be about will GCCS in India evolve into AI-powered innovation hubs or be sidelined by autonomous agent platforms. The panel has Sanjay Warrior, Vice President, IT and Digital, India Strategy at Vesco, John C. Singleton, Director, Tech Solutions, Burns and McDonnell, Saraswati Ramachandra, Managing Director and Country Head at Lightcast, Manish Mittal, Managing Principal and Country Head, India at Axtria. So do make sure that if you want to be a part of this panel discussion, if you want to watch it, you can surely go ahead in auditorium number 1 and attend it and be a part of it. We're going to be starting the next session in the next 5 minutes.
We are AIM Media House.
Ladies and gentlemen, we also
Born
will
in
be
Nama,
having...
Bengaluru. Built for the world.
Okay, I know that a lot of people must have
We
been
make tech
following
make
the
sense.
attendees
We tell
for a long
stories that
time.
matter.
How many of you have been following him for his sport? Can you please raise your hands? Yes? All right. We're going to have fireside chat at 4:30 in the evening. So do make sure that you go ahead and become a part of it, because this fireside chat is going to be about 7 Olympics, 1 legend, the Leander Pease playbook. And he himself is going to be present there. Leander Pease is an Indian former tennis player. And we're going to have Minsky Awards for Excellence in AI 2025 by Leander Pease, Indian former tennis player. So it's going to be a back-to-back session. And I don't think that if I would have had the time to actually go there, if I wasn't working here, I would have missed it for anything. So do make sure that you become a part of the fireside chat especially. We're going to be starting now with the next session. Quantum technology is on the verge of transforming how we compute, communicate, and detect the world around us. The session will walk us through the exciting promises, challenges, and economic impact of this new quantum era, with a special focus on India's growing quantum ecosystem. We have with us Mr. Arindam Ghosh, JRD Tata Chairperson at IISc Bangalore. He is a leading expert in quantum mission and now leads Quant2D Tech, a startup developing cutting-edge quantum sensing technologies. So please put your hands up for one and only Arindam Ghosh, everyone.
Cypher organizers, and I am going to be talking about, actually when I came here, I got this booklet. It says, the future is here. And if I do my job correctly, I will tell you what's there for the future of future. Okay. So I think you can see the title there. I'm going to be talking about quantum technologies. And I will be going through, first, tell you a little bit of, sorry. Can you, I'll first tell you a little bit about what, to sort of say what quantum technologies are. There are certain myths about quantum technologies. Many people think it's just quantum computing, but it's not so. It's beyond just computing. I'll also tell a little bit about, it's going to come in, hopefully. Can I put the slides on? Yeah, good. So we are all set. Tell a little bit about how quantum technologies are going to catch up or are going to complement the AI, but cutting-edge technologies. AI is one of the main ones. I'm going to then talk about the roadmap that Karnataka, as well as India, and globally, where we are with this technology, and where do you think we will go in the next 5 years to 10? Okay. First, the myth. Quantum technologies is not just quantum computing. There are three aspects of quantum technologies. First, of course, is quantum computing. And quantum computing is a new paradigm of computing that uses quantum physics in its certain nuances. I am going to tell you a little bit because I am with a lot of people who probably haven't seen quantum physics for a very long time. So I'm going to tell you what rather weird aspects quantum technologies are built on. In addition to quantum computing, there's quantum communications, the way we communicate completely in a hack-proof way in the next few years. That's going to be quantum communications. And finally, the quantum sensing and metrology. The quantum technologies will build in a whole new class of sensors that's going to help us in medical diagnosis, help us in GPS-free navigation, and so on and so forth, which is where some of the advantages as well as some of the risks come in. Okay, just a little bit of what quantum is built on. What's the fundamentals of quantum? So we know that there's a classical computer that is there, and you have all the beautiful laptops and very fast computers, the workstations. They are built on classical bits, which are essentially these transistors which are in 0 and 1 state. Quantum is built on slightly different stuff. If you think about these states as a vector, it's not up and down, but just two vectors, then quantum is essentially built on this kind of a situation where these two vectors it can exist simultaneously. I'll give you an example for that. Assume that you look at the person next to you, then you look away. Now, if you look away, you don't know if the person is sitting next to you. So if I ask you, is the person next to you is sitting there or not, you will say, yeah, either yes or no. The quantum world says that's an incorrect answer. The quantum world says the person is there and not there. So this is what is called the concept of superposition. It's actually non-intuitive or counterintuitive or whatever you say, but that's what quantum theory is built on. So this is called superposition of two states, and when we measure, it collapses into two actual states, which means now you turn around and you actually see if the person is there or not there. So that's called a measurement, okay? So this is what quantum theory is built on, and it says that the state can exist in all possible states between yes and no, which is what gives it the power. So now, instead of just 1 and 0, you can live in infinite number of states which are combinations of 1 and 0, which is why a quantum computer in certain tasks will be infinitely faster than a classical computer that you see today, okay? So you can stay everywhere here, all right, or everywhere there. That's how quantum computer works. And now, of course, it cannot be done in the same transistor that our computers are built on, so there are other technologies. I'll not go in that. You use superconductor, semiconductor, various other platforms, you use it. Okay. The little bit of history, because we are just celebrating the 100 years of quantum technologies, which is why the UNESCO has declared this as the International Year of Quantum. For example, what is so interesting about quantum that it has been debated over the last 100 years? So suppose I have this qubit, which is the state of superposition of two up and down or yes or no, and I make two of them, and I what you call entangle them quantum mechanically. Don't worry about you don't understand the word. Trust me, even I don't understand the word. So suppose we entangle them, and then we let it go very, very far away. Say one goes to Mars, other goes to Jupiter. And you have two persons. Say, for example, Alice and Bob. So this qubit goes to Alice, and Alice measures it. And if it measures it continuously, she will get either up or down, yes or no. And it's going to be a statistical sequence of numbers. So if Bob measures it too, in Jupiter, say, very, very far away, the Bob will also get a statistical sequence of up and down. Problem is that if they're entangled, then these measurements are perfectly correlated, and that's tricky. It means as if I'm sitting in Mars and I'm making a measurement, it is instantly affecting the measurement that is being done in Jupiter. And this is what the whole concept of entanglement is. And this is why our man, Albert Einstein, way back in 1930s, didn't like it at all. So he and his friends came up with a theory called the hidden variable theory. And for the next 30 years, that was debated. It was in a state of flux. But then a person named John Bell in Bristol University said that, okay, we can check whether the quantum theory is right or the hidden variable theory of Einstein is right. And it turned out that the quantum theory was right, and for that, proving that, three gentlemen got the Nobel Prize in 2022. So that's a bit of history. We do not understand how this spooky action at a distance works, but over the last 100 years, we have found out a way to engineer it and make a new generation of computer, and that's what, let's go ahead and try to find out what happens. Okay, so there are various ways a quantum computer can be built. There are technologies based on superconductors, semiconductor, trapped ions, photonic qubits, and so on and so forth. There are major companies in the world who are trying to make these quantum computers. What people want now is a roadmap of when a quantum computer will be available with us. For example, IBM says a useful quantum computer will be available around 2033. Google says, well, we will get it sooner. We'll get it roughly around 2029, 2020, 30-ish, using superconducting qubits. Okay, these are superconducting companies which are making superconducting quantum computers. QEra is making trapped ion quantum computers, and then we have IonQ, which is going to say that in about next 5 years, you will have a useful quantum computer which will do certain tasks very, very weird and interesting way. Okay. How does a quantum computer look like? This is a circuit, a computer circuit, superconducting quantum circuit. And on this, there is this bit that I talked about. It's not really a bit of a transistor, but it's a bit made of superconductors. This is then put in a large cryostat, which goes down to minus 273 degrees centigrade, 273 degrees below the room temperature. And that's where this operates. And then there are all sorts of circuits which you do the measurement using RF pulses that goes like this. So this quantum computer will not look like the one which you have in front of you. It will look very, very different. It will occupy a much larger amount of space, and it is going to be far more expensive. Okay. In addition to that, we have quantum communication. Quantum communication is essentially how you communicate, how you send information. Usually, quantum communication depends on single photons. So if you look at the light there, we have about 100 trillion photons that come every second towards us. We need to deal with one of them. And this is what quantum communication is built on. I send you a single photon, you send back to me a single photon. And in that single photon, there are certain ways I encode information, which is usually polarizations and things like that. And if there are hackers which are sitting in the process, then you can detect that there is a hacking going on. And as a result, you can detect somebody is listening to what you're saying, somebody is taking the data away from you, and you can then stop it. So that's how the quantum communication works. So there are various ways. Eventually, the goal will be to have quantum internet, all cryptography. Integrate quantum cryptography into communication system. This is the goal of China has already moved enormously. They are already communicating with Austria and other countries to using satellite-based single photon generation and detection. In addition to that, in about next 5 to 10 years, we are looking at a quantum internet, where all our information around the internet is going to be based on single photon-based encoding. Last but not the least, as I told you, is the quantum sensing and metrology. What can we do with quantum sensing and metrology? We can make a gravity sensing. We can measure the acceleration due to gravity with a 1 part in 1 billion using quantum sensors. Why is it interesting? Imagine two things. One is oil and gas exploration. When you go over the Earth crust, if you see slight change in the density of the Earth crust, you should be able to see if there is natural reserves underneath the Earth crust. So that's one. Second, inertial navigation without the GPS. When an aircraft flies, it takes the different altitudes. Gravity changes with altitude. So aircraft knows exactly where you are, exactly how high you are from the Earth's surface. Hence, navigation without GPS support is one of the major areas of gravity sensing. In addition to that, we can measure clocks, extremely high accuracy clocks. You know, financial transactions, the share market opens in New York and that in India. The financial transactions start at the same time. So we need to find high quality clocks in order to standardize time. So we require a whole class of different displacement sensing and gravity sensing equipments, atomic clocks, magnetic sensing, and quantum radars. For example, using magnetometers based on quantum sensors, tomorrow I should be able to measure tiniest of magnetic fields that can tell me the NMR, the magnetic resonances that we do in our NMR machines when we go for MRIs, for example. So we would like to replace large magnetic fields for biodiagnosis. So these are areas in which quantum technologies are going to come in. I'm now going to go into the economics aspect of it, okay? So, which are the key stakeholders for quantum computing? We are talking about oil and gas. I gave you some examples of it. Sustainable energy. We are looking at typical economic impact in these areas. For example, looking at financial services. By financial services, I mean to say from timestamping in transactions, credit card fraud, looking at ATM machine tampering, for example. All these areas are going to be direct beneficiary of quantum computing and quantum sensing. And we are talking about an economic impact of nearly $2 trillion over the next 10 years or so. So, what is happening in the market today? And the quantum computers have already started, quantum computing companies have started generating revenues. For example, if you take a look at the projection in 2035, we are talking about a market of 100 billion. This is the market of the quantum products themselves, okay? A sensor, or a computer, or a communication protocol. We are talking about a typical market size of about $100 billion. Major share goes in computing and then communications and sensing. The economic impact in 4 or 5 different areas, as I told you, the areas like financial services, the automotives, the medical products, and transport and logistics optimization. Particularly, Bangalore will probably be the first beneficiary of a quantum computer because of traffic system. The best way, a far better way of optimizing the traffic flow will be possible through quantum technologies than probably today's best classical computers. So, we are talking about these are areas, and if you take a look at the recent revenue generation by the major quantum computing providers, we are talking about $1 billion of revenue today, this year, with about a 40% increase per year. Okay, so we come to cutting edge technologies, and I know I am here with a large number of AI experts. I will spend a little time of where quantum and AI come into play. Okay, first of all, there are 4 areas in which we believe quantum will come in a big way for cutting edge technologies today. One is AI and machine learning, in which quantum and AI are not mutually exclusive. They are supposed to be complementing each other. I'll show you a little bit in the next slide. In addition to that, we are talking about robotics. Robotics, because today robotics needs to decision-making and precision in navigation, precision in movements. So a more decision-making robots, as well as those robots which will do more specific tasks, will be affected by quantum technologies, driving automation in quantum manufacturing, particularly making secure communications, authentication, and improved navigation and sensing precision will give robots a whole new dimension. Then third is sustainability and climate tech, and the fourth is cryptography and cybersecurity. Cryptography and cybersecurity are obvious. We are talking about hack-proof and secured communication in the first place. All right, as I told you, let's go deeper a little bit on the AI aspect of it, okay? So what am I going to do with AI and quantum combo? Okay, look at the sentence. I deliberately wrote a long sentence. It's a potentially, it can trigger transformative breakthroughs in healthcare to cybersecurity, but we are really treading into dangerous territory. Today, AI is about learning from very large data sets, getting inferences with very large data sets. Quantum gives it the decision-making power, because you are going to span a much larger space using quantum, and that essentially ends up giving the power that what AI-generated information can do with, okay? So we are going to create something which is an autonomous system that are difficult to control or probably understand at this stage. But hey, that's a fantastic area for an academic like me. I would like to see how does AI and quantum superpose. So how quantum and AI can collaborate in both ways. Quantum can help AI in certain ways, and AI can help quantum in some other. For example, if I look at how quantum computing will potentially solve multiple AI training constraints, the algorithm efficiency, the memory size, the memory wall, and the compute power. Extremely important is compute power. Today, looking at the escalation of computing with AI training, AI models, it's going to be impossible in the next 5 to 10 years to actually sustain the energy requirement, if nothing else. It requires 29 gigawatts of power in order to make, if you project the AI requirement in US alone, which is about 29 nuclear power plants. That's not going to be a sustainable situation. We have to find alternative ways in which we can offload certain computing load to a new technology which will do things much faster in a far more energy efficient manner. Quantum will have to come in at that point of time. Number one. Even other way, how does AI help quantum technologies? Today, AI will help us in finding good superconductor, better superconductors to make quantum technologies a reality. Well, it is already a reality. It's more efficient in the in the future. In addition to that, the softwares. For example, if you look at the quantum software and application, AI can support many of the error corrections in quantum technology. So there's a continuous feedback that is going on between quantum and AI as we go along. So this is what I would like to tell a large number of AI enthusiasts here. Right now, we are seeing some sort of a reappropriation of workforce. We are seeing that people with traditional software understanding and knowledge are learning about AI and getting into new job market. In about 5 years' time, it will have to be a quantum AI combo. So if you need to learn about quantum algorithms, you need to learn about quantum structure of a quantum Python programs in order to run quantum gates so that you can take those and hybridize with your AI algorithm. So in about 5 years' time, I'm looking at a whole range of engineers who will come with a quantum AI combination of training. So we need to prepare ourselves for that. What about investment? So this is something which gives you an idea about how quantum and AI are moving in parallel. So if you take a look at the last 4 years or so, this is how the investments in the quantum technologies and GenAI infrastructure has gone in from 2021, 22, 23, 24. GenAI has really exponentially taken off, and quantum technologies are more or less where, about $3 billion per year or something of that sort. But if we see the VC deal, plain and simple from the deal size in quantum and AI since last decade, this is a very interesting graph. You see, this is in $1 million. This is how GenAI or the AI VC deals have taken place, and quantum is now about to take off. So exactly about 10 years back, where AI was today, quantum is here right now. So this is where we need to now plan, we need to be ready for this quantum revolution that will come into AI and make us a whole different ballgame, a whole new futuristic technology. We have about 5 years' time. We don't have 10. Because of the way the quantum is moving, it is moving faster than what semiconductor industry did about 2 decades or 3 decades ago. So we need to be prepared for this earlier than probably what we are envisaging right now. Okay, so how is the quantum economy developing across the world? And I would like to give you a few examples here. Typically, right now, there are about 20, 25 cluster-based approach. What I mean by cluster, the quantum technologies is, after all, infrastructure-intensive technology. You need dilution refrigerator, each of which cost about a few crores. You need whole very different set of manpower, and you need infrastructure to make devices, for example. As a result, there are about 20, 25 of them with global impact. Boston, Chicago clusters. This is in Netherlands. Then this is in Oxford. This is in Tel Aviv, China, Seoul. So there's about 20 of them. What do these clusters involve? So there are 5 key enablers in these quantum clusters that are building quantum technologies across the world. For example, we need capital investment. We need funding of research from on the government side as well as from the private side. Physical infrastructure. This is extremely important. As I told you, it is an infrastructure-intensive economy, so we need advanced laboratories and facilities. Then 3 is academic institutions. You see, most of the clusters that are there today is a beautiful and a very symbiotic combination of a cluster of academic institution and industries around it. Okay, so you need continuous feedback because quantum technologies are evolving very, very fast, but it needs continuous feedback into breaking the state of the art. Third is, fourth is industry and government partnerships, and the 5th is accessibility for technology, standardization, and so on and so forth. So these are the 5 key enablers in development of quantum technologies, in a cluster-based quantum technologies. Okay, this is an example, the Chicago Quantum Exchange. Look at what it promises. It's the largest cluster which seems to drive the quantum ecosystem, a state-driven quantum ecosystem in the US. It has economic impact of nearly $80 billion in the next 5 to 10 years. It will have about 191,000 highly skilled jobs, directly quantum technology oriented. It already has about $1 billion of investment from the government, as well as the state and investment of the private enterprises. In addition to that, it has essentially teamed up with industry. This is what I was telling you, that it has teamed up with IBM, it has teamed up with PsiQuantum. So it's an ecosystem that governs the local job market and also aiming towards a large impact on the economic of the local Wisconsin region. Okay. So there are challenges, and I have to come to the challenges. And these challenges are extremely important to understand where we are moving to. Because of the strategic nature, and almost every quantum product today are what you call dual-use products. What do we mean by dual-use product? It means they can be used in civilian applications, like medical diagnostics, for example. Also, they can be used in defense or strategic applications. So, for example, if you have this is a gradiometer. A gradiometer, or a gravimeter. A gravimeter is essentially those which can measure the vibrations of the earth crust. So if you can put them near the tsunami area, those near the Himalayan, this is on the Mount Etna, where it is supposed to be a dormant volcanic zone. So if you see vibrations, you should be able to predict volcanic eruption. You can predict other kind of natural disasters. So this is good for society, very good. But in addition to that, the magnetometers, for example, like this, which Sandbox AI has come up recently with, is essentially those magnetometers which can measure tiny variations in the Earth's magnetic field. And hence, you can essentially make your aircraft completely invisible to the radar or any kind of communication with the satellites. So these are essentially boxes that you mount on this. Even the Australian company Q Control has come up with these small boxes. All it does is that it measures the fluctuations or variations in the Earth's magnetic field and hence navigates the drone, for example. So tomorrow, if a drone comes in, you will not know. And this is why the strategic applications of quantum is extremely important for national security and safety. We got to make sure that we are ready and sovereign with quantum devices in the country. So, which is why the problem is that we have got 4 key global problems. First is, of course, human rights, because it is a very infrastructure-intensive technology. You require heavy, the difference between the haves and have-nots is larger, so we have to find a way to solve that. But in addition to that, collaborations. It is, after all, a scientific collaboration at this stage, even at this early stage of, it is possible that there will be a strong, exclusionary tendencies. People who are working in quantum may be denied visa, for example. So having, even at the fundamental science level, okay? For example, policies We need to have dialogues. There are IP strategies, IP policies are not clear. If I make a quantum device with another country, for example, it is not clear which country will own the IP, and because it is strategically important for both. And of course, certain technology standardization. As a result, this was about last year, multiple nations, even at this early stage of the technology, is actually doing export control, multiple quantum products. And if you don't believe me, trust me, this was last week's news. EU has just imposed a strict export control on quantum product. The first restricted items is quantum computer and quantum device, and those components which will lead to quantum products. So imagine this happening in 1990s when the computers were starting to develop. We need to be ready with this technology as soon as possible in order to ensure that we are safe and we can be sovereign in this aspect. Okay. The key challenge in India, I would like to come to that. In India, the situation is a little different. First of all, private funding. I'll tell you a little bit more on that. Then the problem is, although India produces the largest number of, in the world, India produces the largest number of quantum-educated people. But still, our output in terms of technology is abysmally small. And the third is, of course, manufacturing supply chain is a problem in India. We are talking about a hardware development. Many people here, of course, AI, we have our computing resources, and often those computing resources can be now be bought, and hence it can be made somewhere else in the world. That option doesn't exist for quantum. Okay, and the third, of course, the regulatory aspects, the customer protections and risk mitigations. These are also at a very early stage as far as quantum is concerned. Giving you an example of what we mean by India's problem of private funding. So this is typically how much the federal government in quantum has gone in. It's about $54 billion. The circle size is roughly which a particular country has invested. The federal government of the country has invested in quantum. India has not bad. India has actually, look at this yellow dot. It's about $1 billion, about 1.5 billion, including our national quantum mission. However, if you take a look at the next slide, it will be very interesting. The green, the blue ones are the federal government, which I showed you in the previous slide, and the red one is essentially how much the private funding has gone in that country with respect to the federal government funding, which means that in the case of America, this is $3.8 billion have been given by the government, and the Googles and IBMs and Microsofts, they make about $4.3 billion. So that is why there are more than 100% of the funding to quantum has come from the private sector. If you take a look at Europe, it is less, and you have about 5 to 10%, depending on the country, of the private funding. If you take a look at Asia, China has put in the largest amount of money in quantum, about $15.3 billion, and that essentially is off the chart. And still about in Asia, most of the countries, the private component of the funding is in the order of 5% or so. In India, this is the problem, that we have just about 0.2% of the federal government funding has come from the private funding. So we got to give our private companies, like the Infosys, like the TCS, Tatas, like the Adanis, like the Wipros, that the option of buying computing time and running your business is not going to happen in India. We got to make your own hardware and run your computer, run your services from within the country, because tomorrow you will not get buying time from quantum computing. Okay. So despite large number, the problem of funding, of private funding, has actually caused people not to take quantum technologies as a viable career option. For example, as I told you, India produces 91,000 quantum-educated undergraduates in 2021. It is pretty much the same. It is the highest in the world. But if you take a look at the output from India in terms of patents and publications, it is extremely small. It's right here. look at the comparison to EU, US, China, etc., etc. So we got to start making our own IPs in this direction. Okay, so this is what is happening in otherwise the situation. The government has just come up with the National Quantum Mission, and one of the goals is to create the infrastructure. It's about 6,000 crore investment in various aspects of quantum. In one of the major aspects is skilling the human resource. We just started the undergraduate program in quantum in 9,000 colleges, which is approved by the AICTE, All India Technical Education. We also just started the MTech program in quantum technologies. And in the next few months, a laboratory will be available for extremely large number of colleges to start their own quantum education program. In addition to the national initiatives, now the states are coming up. Different states, originally Amaravati Quantum Valley has just come up from in Amaravati, in Chandrababu Naidu has just started this Quantum Valley project. The idea out there is that they're going to buy a 156-qubit quantum processor from IBM and then provide it on the cloud so everybody can actually start computing using the time that is going to be there. Quantum mission in Karnataka was announced. I guess you have seen this in the newspapers of late. Quantum City, which is called a Q City, has now been announced with a state government combination contribution of about 1,000 crores. So hopefully this will kickstart quantum activities in Karnataka in the next few months or so. I'm going to give you a little bit about what we are expecting from the community, about why we essentially need to have a holistic approach to quantum. Just buying a computer from a company and then giving you the computing time is not going to be the sustainable solution for quantum technologies. For example, how do we bridge the supply chain? So a core quantum product is a quantum circuit. This is there. We have in several places in the country. IISc has it. TIFR in Mumbai has it. So there are some places in this has the core quantum product. We also have now we need to create this quantum associated product, which is like a dilution refrigerator. Yeah, 5 more minutes. And then we require a quantum beyond quantum product, which means, for example, the microelectronics. So this whole thing forms what you call a quantum ecosystem. Okay? And if you take a look at recent companies that are coming up, they are making small products, just a filter in the dilution fridge. Even that is a $1 billion business today. And that is why if you see the companies that have come up in the last year or two, they're all in the hardware, in the equipment, small equipments, as well as software and algorithm regime. So what I say that if we have a global market to go to this, we need to have, and in which a real quantum computer comes in next 6 to 7 years. We have about 30 startups right now in quantum domain. But if you are an expert in, for example, a software algorithm, PQC, the post-quantum cryptography, if you are a material expert, semiconductor, nanomaterial, or whatever it is, if you are an expert in microelectronics, for example, or if you are an expert even in heavy industrial manufacturing, we require you. We need all these 6 or 7 different areas must come together into building this ecosystem. And that's essential for quantum technologies to get the sovereignty in quantum technologies. Okay, I'm nearly done here. I'll just give you a sense of what we should prepare ourselves for. Okay, this is the last one. You see, quantum, there is something called a Q-day. A Q-day is the definition, is that the point at which the quantum computers will break into our classical encryption and then make all data that we have viable to attack. This is what quantum computers can do. It will actually hack through it once it's in full form. it can actually factorize the Shor's algorithm. It will see the current encryption. It will break the current encryption fairly easily. Typically, today's encryption, the RSA 2048 protocol, which is considered safe to 2030, a quantum computer today will break it in 26.7 hours. Okay? So that's called a Q day, when the encryption is breached by a quantum computer. And the impact of the Q day is essentially sensitive data essentially becomes vulnerable. Organization and the governments face immediate need to implement the post-quantum cryptography and quantum key distribution to safeguard this data. And the features will be essentially the breakthroughs in quantum algorithms, and this is happening. So question is, when do you think this will happen? Okay? So if you take a look at the way the infrastructure is growing, so this is typically how the roadmap of industries in terms of the resource. Physical qubit is the resource for quantum, right? Typically, this is how we have moved. The amount of qubits that we have in our hand by the industry. This is approximately the dashed line is the reality, what we have achieved in hardware. So it means essentially that what the industries have predicted, our hardware requirement actually our hardware development has actually followed that. So it is actually moving with the expectation of the industry. Now, what is the resource required for breaking the RS-2048 protocol under the encryption? That has changed over the years. Essentially, this is the hardware requirement for breaking the RSA-2048 protocol. And as a result, if I have a quantum computer, this is roughly the date from anywhere from 2027 to 2034, 33, 34, there is a chance that our encryptions will be breached and the computers will take the data. Okay, of course, at this point of time, we are working on post-quantum cryptography, making better protocols to safeguard our sensitive data, but this is roughly where things are going to happen. I'm done. This is my last slide. There are certain industries' expectations, but we are trying to keep up. However, I always end with this picture. In 1943, Thomas Watson said that there will be market for 5 computers. Clearly, that was wrong. So the future is something that is rather unknown, and we must be ready for any eventuality. Thank you very much for your attention.
Ladies and gentlemen, if you have any questions, please go ahead. Okay, we only have time for 2 questions.
Hello. Yeah. What do you think is more realistic, AGI or quantum Q-day, as you said?
Separated in very clear way. I think both of them are equally important, and they will move in parallel. Q-day is going to be a reality. There is no doubt about that. Question is that it's probably when. So I think both of them are as essential to pursue as, you cannot really prioritize that way.
Here, sir, thanks for the very insightful presentation.
Thank you.
I'm Priyesh, I'm work in Paytm. So, sir, my question is regarding, as you mentioned that India is lacking in the private investment for the quantum. So what other challenges apart from investment do you see that lacks India to become the leader or at least the global player in the quantum in the next 5 years? And what should the youth or the people like us should primarily focus currently to understand about the quantum?
Right, great question. So 2 aspects. First is essentially the skilling part. We require students now to be educated in quantum algorithms, in quantum aspects of technology, as during their early undergraduation, so that we get workforce. India lacks workforce, number 1. Number 2, India lacks sensitivities in how they can contribute to the development of quantum even at the MSME level. So there are a large number of companies, MSMEs, who actually have a very large solution for the quantum hardware and quantum ecosystem development. The problem is we do not have the information that we actually can contribute and actually can make money in the quantum economy. So these two are the most important aspects as far as we are concerned. We are trying to ensure that we create a critical human resource and also educate the MSMEs, industries, that how they can contribute to the economy and how their product can enrich the economy.
We can take 2 more questions.
Hello.
Yeah.
Yeah, my name is Jatin. I wanted to ask, like, what are the challenges of quantum to be commercially successful?
Okay, so the one commercial product of quantum is already there. For example, the times keeping, the clocks. Now, when you say commercially successful, in quantum, tomorrow quantum is bound to be commercially successful because it is going to give you certain things which no other technology can give. If quantum and AI are put together, tomorrow any company is going to go for quantum AI hybrid solution than only AI solution. Because A, you are going to spend much less energy, much less time, and hence produce much better products, number one. Number two, there are certain products that quantum will give which is simply not going to be available in classical technologies, right? A gravimeter is the product which will come only from quantum. So there is no way you can buy it anywhere else. Thus commercial success is guaranteed.
Yeah, and I want to ask last thing, like in research, today's quantum stakeholders are believe in philosophy of Einstein or Niels Bohr.
Well, they are not too different. Einstein has already been proven wrong in this case. Niels Bohr is right. So quantum does not depend on Einstein's ideas anymore.
Thank you. Thank you.
Hi, sir. What needs to change so that we get more quality papers in quantum research?
Infrastructure. So we need more infrastructure, and that's what the National Quantum Mission is for. We need to have those infrastructure distributed across the country. We need more people to do hands-on experiment. For example, so we are now having quantum programs, MTech or BTech or whatever it is. So they are trained in both experiments and algorithm aspects. So today, quantum success in quantum will depend on the infrastructure availability and where the students get understanding of what radio frequency engineering as well as how the quantum algorithm works. So that's the way we will be successful.
Thank you, sir. Hello, sir. I have.
Yeah.
You talk about infrastructure and like quantum computing and AI. So one of the limitations that I was reading about is data loading, like essentially encoding classical data into
a quantum hardware,
quantum states, basically.
Yeah.
So how expensive is that in compared to the classical AI methods that we have? Like,
right.
Is it more expensive or less expensive?
At this point of time, it is more expensive, and it's a question of time now. Yeah. For example, today, a quantum computer that you have is about 156 qubit quantum computer, which is very small.
Yes.
But if you look at the roadmap, we are talking about 10,000 qubits by the time 2028 comes. Yeah. Okay, this is about 2025. So when you have 10,000 qubits, now this becomes cheaper. Yeah. It's exactly how the electronics industry has moved. Yes. So we need to be ready with our algorithm, we need to be ready with our programs. So the moment in about next 2 to 3 years, that many qubits are available, you are going to see a de-escalation of cost, and you are going to use the quantum and HPC hybrids.
And it is also true for QRAM as well, right?
Yeah.
All right. Thank you.
It is.
Yeah.
Hello, sir. Sorry, the last one.
I'll have to cut you off. I'm so sorry. We're out of time. Thank you so much, Arandam, sir. Thank you. In today's fast evolving AI world, seamless communication between autonomous agents is crucial. The session will take us on a deep dive into Google's agent-to-agent protocol, an open standard enabling diverse AI agents to collaborate efficiently across platforms. Our next speaker, Shubham Agnihotri, is a senior data scientist specializing in generative AI at IDFC First Bank. Shubham also leads community initiatives like AWS User Group Mumbai and co-founded an agri-drone startup that saved millions of liters of water and reduced pesticide use significantly. Ladies and gentlemen, Shubham Agnihotri.
Am I audible till the back? Perfect, awesome. So before I start, I would like to thank AIM for having such an amazing event and for you guys to turning up on a working day. So before we start, it was a very warm I'm fine with this as well. That's fine. Yeah. Perfect. Okay. Okay. Let's start again. So pretty much I have around 6 years of experience. I work as a senior data scientist, lead the vision vertical with 9 amazing engineers at the Generative AI Center of Excellence at IDFC. So when I'm not working, I work with communities around, give sessions. I was in Singapore this year and will be traveling to Dubai and here in Cypher. And when I'm not working, pretty much I'll be traveling. So coming back to the topic, A to A protocol. And few years back, ChatGPT was released to public by OpenAI and there was a disruption in the market. A lot of things started to evolve rapidly, where new and new models came into existence. Every now and then on LinkedIn, on X, we see companies releasing models, new frameworks are being released, and this year was a year for agents. So today, what I'll be covering majorly is what are agents. A lot of you guys might be data scientists, AI engineers, CXOs of various companies, might already have different workflows for automating tasks, reducing manpower, optimizing things. So how are they different from the agentic workflows that are coming in being? Then comes the A to A protocol released by Google. So what exactly is the A to A protocol? Why do we need that protocol? What are the key components of that protocol, which is your agent card, agent communication, and agent execution, how things become seamless after this. I'll also be covering another protocol from Anthropic, which acts as a complementary for A to A, making agentic solutions really seamless. So what I'll be talking about is how is it different from A to A, and why do we really need that? And then a combined framework on how we can leverage A to A and MCP together for our own solutions. So what basically are agents? Before I come on to this, how many of you guys are AI engineers here? Okay, few of them. So that's good. So this session will be for all of you guys who are working in the industry as an AI engineer or data scientist, or who are from the business domain. So what exactly are the agents? By the definition of it, it is basically a software which interacts with an environment it has been provided in, collects some information, and based on that information, it defines a set of tasks that it needs to perform in order to achieve a goal. That goal can be set by the human, But the task it takes and the data it uses is something AI itself decides. So let's take an example. So I work for a bank. We have customer call centers. We have various modalities by which a customer can reach out to us. It can be from emails, WhatsApp, text messages, phone calls, video calls, and whatnot. So let's think of an agent. Let's think of a person or an agent that is solving these customer queries. These information extraction or exchange can be majorly on, let's say, it's an upsell to the customer. It can be a query resolve. It can be an additional request, anything. So let's take an example where the agent interacts with the customer. It asks the relevant set of questions, retrieves the data from the bank's repository, retrieves the customer's persona. Based on that, devises a set of solutions or set of tasks that it needs to perform in order to address that query, and then has to execute those operations. It can be creating a service request. It can be asking additional information. And based on that, then it has to decide whether the end goal was satisfied or not. If yes, then it may close the request. If not, then it has to bring in human in the loop. Very autonomous, very simple problem statement, but very complex to implement from the earlier ways how we used to develop solutions. So a lot of you guys might be working in corporates where there are simple repetitive tasks now done by AI. And what we also see, since agentic AI is really a thing right now, where a lot of hiring has gone down and a lot of repetitive tasks are now being automated from AI. So what exactly is the difference between a standard AI workflow with an agentic workflow that we have? An AI workflow is basically a simple pipeline where you define a set of tasks that it needs to execute with a certain set of parameters it has and a defined objective. Yesterday I was at a restaurant and I ordered a dessert. So let's try to link it back to the AI workflow that we have. So the chef looks at the ingredients and looks at the recipe and formulates the whole dish and prepares the dish and give it back to me. Now the same thing in an agentic environment would be where I don't tell that this is the dessert that I want to prepare. I say, okay, I need a dessert. And then the chef asks me, what are your preferences, looks at the ingredients, and then devises a recipe. And from that recipe, it creates the dessert and gives it back to me. Fundamentally, this is how a normal AI workflow is separated from an agentic workflow on these 4 parameters. One is decision making, where AI agents work in a very dynamic environment. They create their own set of processes. They decide what tools to use, what models to invoke, and once the output is ready, what exactly to do with the output. And then when it comes to an AI workflow, it is very static in nature, where there are predefined steps that it needs to follow, and a very deterministic output. AI agents are flexible to unknown situations, like the customer call center agent, where a customer can ask any query, whereas that is not the case with an AI workflow. One issue with these agents are the complexity, the sheer complexity it comes with. They are very prone to unreliable, sometimes illogical, and sometimes they go on to an infinite loop. So that is where the engineering aspect comes in. A sophisticated design is required to implement these agents, whereas AI workflows are very easier to debug, very easier to iterate, reiterate. And again comes the control, because they are autonomous in nature, harder to control as compared to the set of predefined tasks that we have in the AI workflow. So that gives me a very good segue of coming to the topic, which is A to A. So What exactly an agent is, think of it as a smart assistant. Think of it as a subordinate where you give it a task. It has its own understanding of the task. Based on that, it has access to certain set of tools. And from those information, it devises set of steps and generates an output or performs a task and reports it back to you. So this is one agent. Now, in such a case, in today's world, there can be thousands of agents. It can be vendors. It can be your own personal agent. For example, let's say a Google Assistant or a Siri. It can be your cab booking agents. It can be your e-commerce agents. So let's think of a scenario where why do we really need an A-to-A protocol or an agent-to-agent interaction protocol? I would like to walk you through an example, a very simple real-world example that pretty much every one of you guys faces, and how A-to-A protocol solves it, and what are the constraints when it comes to the current implementation. A very simple scenario, I want to watch a movie. I call a friend. I say, I first check on various platforms. What movie is available? What is the venue? What are the seats? What are the timings? I call a friend. I look up at my calendar. He looks up at his calendar. And then we decide, OK, this is the one that works for both of us. We book the movie. We book the cabs to the venue. And that's it. Very normal, very realistic scenario. Now let's see, when it comes to agents, how complex it becomes. So there is my own assistant. For example, it can be, just for example, I'm taking it can be a Siri, where I just say, OK, I want to watch a Marvel movie. And first, it needs to understand, for booking a Marvel movie, what exactly I need to do. What exactly is the platform I need to go at? Which is the friend I need to ping? It needs to understand what are my available slots. It also needs to interact with the movie agent. It needs to interact with the friend agent. Once it is being booked, it needs to interact with the cab agent. Now here's where the complexity lies. My agent does not really know what these agents perform. My agent does not really know how to interact with them. So there is a certain set of request response that, let's say, a Book My Show is doing, or let's say a Paytm is doing. Similarly, an Uber is doing. And so maybe I might have, so there are a lot of vendors in the market for agents. It can be a crew agent, or it can be a LangGraph, or a small agent. My agent might be written in, let's say, the Hugging Face small agent, whereas the Paytm might be written in a crew.ai or their own framework. So I need to make sure that it interacts really well with them. And that is where the challenge comes in. So what A-to-A protocol does is A-to-A stands for agent-to-agent protocol, where it standardizes the communication framework that allows agent to interact with each other in a very consistent and a predictable way. It enables the independent agents. It can be humans, for example, my agent and my friend's agent, or any software-driven or AI-driven, the vendors that we have, to safely communicate, collaborate, and coordinate tasks. And one more beautiful thing about A-to-A protocol is that it abstracts out the framework on which your agent has been built on. Therefore, it enables interoperability. Now, the same scenario with A-to-A. Now, addressing the three key problems. What is that out of the plethora of agents that I have access to, think of agents as your DNS servers, or let's say DNS in your internet protocol, where for let's say google.com, I need to ping at 8.8.8.8. For agents, how do I really know that this is the task that it needs to perform? So the first issue is, from the list of agents, what exactly my agent can do, or what exactly these agents can do. That is where the first key component of A-to-A comes in, which are agent cards. They are your identity cards, very similar to how we have it in Aadhaar. But majorly what they do is three things. One is the capability discovery, where they tell that a cab booking agent can book a cab, an e-commerce agent you can buy items from there. A food booking agent, you can you can order food, you can book reservations, you can book tables. Task management, which is something very key when it comes to agents, because, for example, think of a scenario where I'm traveling to Bombay, traveling to Bangalore from Bombay, and I take up my phone and say, okay, I need to book my hotel, I need to book my flight, I need to book my cab, and I'll be spending a couple of days here, so I need to book my recreation activities and various other things on that. So this whole process takes time. It cannot be within few seconds, and our protocol cannot time out. So that is where the task management comes in, and then comes in the multimodal support, where the agent not only interacts with in text, but also in images, audios, videos. Yeah. So this is how basically, this is a bit more technical, where this is how an agent card looks like, fairly simple, where you give a name, you give a description, you give the URL where it is hosted at, the version, the default input it expects, the default output it has to produce, and the most important thing, the skill set. Think of it as your LinkedIn, where you define what are your skills. That is where we define the skills of our agent, where it can book a cab, it can book a hotel, it can book a movie, it can reschedule a movie, it can cancel a movie, and whatnot. So an example of it, where it's a cab agent, where I give a description about what my personal cab, it books your personal cab, and the skill set where it says, okay, book a cab, a description that, with the skill set, I can move from one location to another location. And the beautiful part is the examples, where I can specify that these are the set of intents that a user might use in order to call this agent. For example, book me a cab from X to Y, or schedule me a cab. So with these kind of information, when I give a query to my agent does a search and figures out, okay, these are the relevant agents that I need to call. Therefore, it solves my problem of what agent can do. Now, how do I communicate? Because there is a certain way in which there is a certain request response structure in which, let's say, the movie agent might be written or a cab agent might be written. So how do I make sure that they interact properly? So that is when the second key component of A2A protocol comes in, which is the messages. All the data scientists and AI engineers might be very familiar with this structure, where this is how we interact with OpenAI, where we provide a role. Over here, instead of a user, it will be an agent. It will be my agent. The parts where I say, okay, this is the data type and the information. It can be the command saying that, please check with my friend when he is available for this movie. And then there'll be some meta information, message ID, task ID, and context ID. And what it does in return is gives us two critical things. One is messages, second is tasks. The task aspect is something which is very crucial when it comes to A2A. And so first, let me cover messages, where the same example where I said, okay, I need to book a movie. And okay, so it'll go to the movie agent, it'll fetch that information out, and it'll give me in a form of text saying that Marvel is let's say Avengers is available at these locations at these times. So that is where the message part comes in. Then I say, okay, book me at this location, at this venue, book me these 2 tickets. Let's say book me 2 tickets. Then the agent goes back to the movie agent, and then it again comes back with the input saying that, what I need is what timing are you looking for, and what are the seat that you're looking for. That is where the state of the task comes in, where we have something called as submitted, something called as working, For long-running tasks, it will be in working, so at least my agent knows that it has not crashed. So it still needs to wait for it to be executed. Then there is something called as input required in the example that I gave, where it is asking input from the user. Then it is completed, cancelled, and failed. Okay. So now now I know how my agent. Okay, got it. Yeah. So now I know how my agent can interact. Now when it comes to how my agent can, I'll be in the here. Is this fine?
Is it working?
Hello? Am I audible at the back? Yeah, it's working. Is this laid fine? Perfect. Okay. Awesome. So now the final thing is how these agents execute this task. That is where the final key component of A2A comes in, which is your agent executor. A very simple class where you technically where you just inherit agent executor class, and it gives you two abstract functionalities. One is execute, second is cancel. In execute is the place where you write your code on what exactly is the task that it needs to perform. The code in your skill set that I need to book a cab. So what it needs to do is it needs to take in these information. That is your source, destination, timing. And in the back end, it needs to call the relevant databases, do the relevant function calls, and make sure that this transaction is completed and give you back the status. That is, whether it is completed, the state that I was talking about previously. And then there is the cancel functionality, where pretty much if you want to cancel it out. Yeah. So this is how the whole overall structure looks like, where now I need to book a cab. This is me. I have a client agent, which is my agent. What it does is, okay, it looks at all the agents in the list. It finds out, okay, this is the one that I need to ping. It takes the relevant set of information from me. It uses the messages to communicate with the other agent. Then the other agent performs set of tasks. If there are certain set of inputs that are required, it will revert back with these are the inputs that are required. My agent will look up, either will look up in the database and check whether these information is already present with it, or will ask me or prompt me. And once that is done, once that information has been passed along, then that is where the whole transaction gets executed. So when agents interact with each other, or they perform a certain set of tasks, what they are actually looking at is a certain set of information via which they can define the steps and they can take those actions. So where does this information pretty much comes from? So in the whole scenario where I was talking about I need to book a cab, I need to book a movie ticket, I need to find my friend's availability, I need to look at my availability. So what my agent was pretty much doing is, it was looking at my calendar. It was, whenever it was making a transaction, saying that, okay, I need to book a movie for these two people under this account. So it was passing that information that, I am making a booking for Shubham. Or whenever it was booking a cab, it was booking a cab for Shubham. So how is this information being passed on to? So that is where MCP plays an amazing role over here. So what exactly is MCP? So MCP stands for Model Context Protocol, where it is an open source protocol from Anthropic for connecting AI agents to external systems. Over here, the AI agent can be a software, it can be your personal assistant, external systems can be data sources, it can be tools, it can be various workflows. So what it does is it enables them with all these kind of information. So let's understand, why do we need MCP? Same old example. Now, Shubham agent, what exactly it needs to do is it needs to connect with Google, or it needs to connect with my company's Outlook to understand, okay, these are the set of holidays, these are the set of time where I am available. Then it needs to look up with my credentials at Uber or Ola. It needs to look up at my credentials at Book My Show. It also needs to have access to my payments for it to successfully execute any kind of transaction. And the same thing also has to happen, 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 also has to happen. To 10 number of agents, and I need to make sure that this connection stays intact. And similarly, if I have another application, I need to perform the same thing, and that pretty much violates the dry principle that don't rewrite or don't reuse. So what MCP comes into, how MCP comes over here is, MCP does very simple task where it says, I'll be the orchestrator. What you exactly need to do is, your application should need to connect to me, and I'll be making sure that I connect to the tools. So it acts as a middle layer where now my M cross N problem becomes an M plus N problem, where my M applications needs to connect to one server or N number of servers, however I'm maintaining it out. And my N tools, it can be my Google, it can be my local storage, it can be for a corporate, it can be the AWS S3 or Azure Blob Storage or whatever you are connecting at. And so the server connects to those N tools, and it therefore becomes an M plus N integration. So there are majorly three components in an MCP, where we have the MCP client, the MCP server, and the MCP protocol. MCP client is the application that will be running on my end, that will be looking up at all the tools, resources, and prompts available to me via the server. MCP protocol is basically the communication channel via which I will be connecting to the server, getting those information, executing those calls, executing those tool calls, and performing those set of actions. And MCP server is basically my, consider it as a universal connector that will be connected to all the set of tools, and it will be performing those operations or transactions or executing those codes. So what exactly is the difference between an MCP and an A2A? So MCP's work is to empower an agent from connecting it to various tool sets, various information it has. Whereas A2A focuses on connecting an agent to an agent. The primary use of MCP is to extend an agent's capability, whereas A2A focuses on a multi-agentic framework. MCP focuses on function calling, where a lot of data scientists and AI engineers might have used function calling, where they want an output in a very structured format. They want the model to execute certain set of functionalities, do certain set of function calls. So that is where MCP comes in. Whereas with A2A, it is a lot more conversational, where English text goes in, English text comes out. Or let's say the modality that we are operating into. Then comes task handling. MCP is individual command focus, saying that, okay, I need to book a cab. So it needs to, let's say, update a database saying that, okay, Shubham needs, or let's say, let's look at an example of I need to book a movie ticket. So it needs to reflect it back to all the customers. So what it'll do is, once I book the movie ticket, there has to be a function call, or there has to be a call where it updates the database. That is where MCP comes in. Whereas A2A pretty much looks at handling long-running tasks with lifecycle. Discovery mechanism for MCP is via tools. Tools are basically a set of functionalities, whereas A2A is from the agent cards that I discussed before. And the implementation is majorly a very low level when it comes to MCP, and a bit higher level when it comes to A2A. So this whole example now we'll walk through with how we can achieve it a bit technically via A2A and MCP combined. So there is this agent, there is my agent. I can be running on any kind of an LLM. It can be a Gemini, GPT, Claude, or your own LLM that you want to train on, or an SLM. And I can be running on any framework, which is, it can be a LangGraph, Crew AI. Google has its own ADK, Agent Development Kit. Then it has AutoGen. And then there can be another agent. It can be the booking agent, having the similar kind of stack. Now, I need to make a booking. Now it is working. Yeah. Anyway, it's just 5 more minutes. So should I? Is it working fine? Yeah, perfect. Can I continue? No worries. Hello? Okay. Yeah. So, let's run back the example where it is my agent running on, it can be on any model, and it can be running on any framework. And let's talk about another company's agent. It can be the cab agent or the Book My Show agent or Paytm agent or whatever. It can be running on any of the frameworks. So for my agent to understand that what is Shubham's calendar, what it will be doing is it will be doing a call to Google and fetch my calendar. That can be the API and enterprise calls. And similarly, for the Book My Show agent, what it needs to do is, okay, it needs to update its database. So what it will be doing is it will be connecting again to its own tools, connecting to its own tools, its own database via the MCP protocol, and will be updating those tasks accordingly. And so this is how the whole queue looks like, where we can maintain an agent-to-agent messaging queue. And if in that whole queue, if you want to look at the observability and CRM or any kind of application that you want to run at, so this framework pretty much works with any kind of task that you really want to work at. For example, if I want to book a cab, what my agent will do is it'll use this framework. It'll call the cab agent. If I want to book a movie ticket, the same framework, calling the movie ticket agent. If you want to perform a very big task, what it'll do is it'll be utilizing the same framework with, let's say, if I want to book a full-fledged travel itinerary or let's say travel booking, so it'll be calling multiple agents over the same queue and will be executing those tasks in sequence. So yeah, that brings to the end of my session. Feel free to connect to me on LinkedIn, and I'm open for questions. Sure.
Great stuff. Just that one thing was not clear when you were showing that graph of agent and MCP comparison, the linkages, the lines. Can you go to that particular chart?
Okay. This one?
No, before that. Before that? No, before that. Yeah, in this one. So why in MCP it's only connecting with tool 1? Why it's not checking tool 2 and tool 3? How does it know that the tool 1 is the right one for app 1? Because in the first one, it's checking with all 3. The app 1 is checking with tool 1, tool 2, tool 3 to see which one is the right one.
Yes.
But in MCP, app 1 is only connecting to tool 1. So why only 1? Why not tool 2 and tool 3?
So basically, app 1 is connected to all the 3 tools. So app 1 is connected to the MCP server. MCP server is connected to the tools. So how does an MCP server
decide that it should go to?
Yes. So that is where the task of a LLM comes in place, where again, if I go a bit more into detail of how tools are defined, that is where how agent cards are there. That is in a very similar way, tools are also maintained that tell, okay, these are the set of functionalities I can perform. And so it's again kind of a lookup where the LLM looks up and identifies, okay, this is the right set of tools that I need to invoke, and it performs those operations.
The MCP decides.
Yes.
So it could have connected to tool 3 also.
Connect, yeah.
Thanks.
It can.
Any other questions? Can you please pass the mics?
Hi, I'm Akash Kapoor. I just wanted to, this way.
Sorry, okay, perfect, yes. Yeah, Akash.
All right, so I just wanted to check, agents are actually for a specific purpose.
Yes.
Right? So a strategic purpose they are solving. What is your thought instead of agents if we have SLMs? Won't that be a better option rather than having a big LLM actually and then dividing them into agents and then agents actually working for a strategic purpose?
So agents in the backend use LLMs. Instead of an LLM, you can use an SLM. That's also fine. So if I go back to this example where over here, it is up to the user which model they really want to invoke. So if you have a very fine-tuned SLM, for sure you can go ahead with that for your use case.
Hello. Yeah, can you hear me? Yeah, straight.
Yes.
Straight, yeah.
Okay, yes, yeah.
Saurabh, you were talking about the agent to agent. Can you talk about authorization and authentication? How does that happen?
Okay. So basically, there are two things that I'll be addressing over here. One is authorization, authentication for payments, because that is where the sensitive information comes in. So 2 days back itself, Google released a protocol called as AP2 that stands Agent Payment Protocol. That pretty much takes care of that. Second is, if you are looking for not so sensitive information, what you can do is in the A to A or something like that, so you can pass in your keys, you can pass in your API keys, and via which you can do the whole transaction.
Thank you.
Yeah.
Hello, can you hear me?
Yes, I can hear
you.
Okay, at the back, yes.
Yeah, so I'm Soumya, and my question is that in terms of scalability and interoperability, I understand that A2A is a very good tool to have, since maybe you are working with very specialized frameworks. But don't you think that when you are trying to scale using different frameworks for specialized tools will create a challenge?
It will create a challenge. That is where A2A comes into being, because I cannot control what other company is deciding on the framework they need to work at. So for example, I work at IDFC. IDFC creates an own agent. Let's say Paytm decides, okay, I want to work at Crew. And let's say BookMyShow says I want to work with LandGraph. So I don't really have the flexibility to force them to work on one single framework. So that is where A2A comes in and says, okay, irrespective of whatever framework you're using, I'll make sure a transaction takes place or communication takes place between you guys.
Last two questions, guys.
Last one, Shubham.
Yeah.
Fantastic one. Very future looking, right? Really good to see that. See, I have some questions about the operational part, right? When we interact with an agent, if it becomes so much iterative, right? For everything we need to pass on a message, then we get options and all. At times it becomes a little cumbersome, right? You answering or feeding the agent on every step. So do you see the forward-looking view when agents can become as intelligent agent? Because a lot of our behavior, a lot of our preference, a lot of our patterns, right, which gets recorded. Do you see this evolving where it will further come out with recommendations rather than just giving us the options which are available, which will make it much more personalized, the way it interacts?
Correct. So definitely I do see that happening. So there is a concept called as memory that comes in. So it is also there in ChatGPT. ChatGPT also has agents connected to it now. So what those memory does is basically stores the key information about you, what do you like, what do you dislike, or what are the basic information that the agent should really know for performing any kind of a transaction or an operation. For something specialized, it'll still ask you, but otherwise it'll pretty much fetch in those information from the backend memory that it has, and it'll display you that these are the things that I'll be, inputting into, so that it does not, so that you don't really need to give your more inputs on that. So yeah, agents with memories will definitely solve this problem.
That will be helpful. And the second part, I believe you have already addressed that about the payment authorization and the approvals. That will be the key where you need to actually close the transactions out there.
Yes, so 2 days back itself, I think when Cypher started, that is the time when Google released AP2. You guys can have a look at it. So it's fairly new, so even I need to get brushed onto it, so what exactly it performs. So yeah.
Thank you very much.
Yeah.
Last question, guys.
Hello, am I audible?
Yes.
Yeah, you're over here.
No, he already started, so. He's been trying to ask the question, and he already started, so let's give it to him. Yeah, thank you.
First of all, amazing session. Really great to see the tech side of it. In A2A protocol, you mentioned about agent cards, right? Yes. That also contains the information about the skills of that particular agent.
Correct.
So, and when we are talking about MCP, so that is also giving me the information about the tools an agent can access.
Correct.
So what's your view on whether A2A can be extended, like, having an interface and just completely replacing the MCP call? Because if you see, both are somehow overlapping the details of an skills and the tools that agent can access.
Correct, and a very good question. So the functionality of both the protocols are very different. A2A focuses on multi-agent support, whereas so that is where the linkage between MCP and A2A comes in. And so definitely, so if you're talking about the functionality in the agent card, the skill set that we are mentioning, so in the skill set, if I talk about technically, you'll be defining a function, and that function in turn can call an MCP and perform those kind of operations. So MCP takes care of tool handling, whereas agent to agent takes care of how to interact with other agents. So that is where the overlap is.
Yeah, thanks.
I think we still have 2 minutes for last question. Please go ahead.
Yeah. Sorry for the previous time. So you have mentioned about agents, you have mentioned about A2A and MCP both. But I think a key thing that was not discussed till now was about prompts and the prompting that is required. So I have also been working on AI agents. I've designed AI workflows. And a key issue that I still face to this day, even with best models like Gemini or Cloud, is that whatever workflow that I have preset, right, I've mentioned in my prompt, I've discussed a task and goal. It's still, it's difficult for the agent to continuously follow that same workflow, to maybe invoke the correct tools to, do the task. Many a times it fails to do that, even though in the prompt you actually clearly mentioned that. So I just wanted to know if you from your end have any tips or anything that we can do differently to ensure that our AI agents actually perform the task every time?
To be honest, this is a problem that pretty much everyone faces. And the more better the models get, the better your interaction becomes. So agents, again, as I told, it is a fairly new thing where an LLM is asked to perform so many tasks at the same time, where sometimes it hallucinates, sometimes it may give a wrong result. So that is where, so what we do is, there's a lot of stress testing that you can perform before it goes to production, where you can, so what we also do is we stress test our prompts over a plethora of use cases, where then again there is a threshold that you keep that after certain, like let's say it passes 95, 96, 97% of the cases, then you are okay to have 3-4% of the cases being dropped off for that. Rest, yes, advanced prompting techniques, chain of thought prompting, few shot prompting, everything is already in there. So pretty much you might already be using all of that. So it's just how the technology evolves, this problem will reduce. Hallucination have already gone down less with newer models. So yeah, we're just waiting for the next best model to come up.
Okay. Thanks.
Thank you so much, Shubham, for this amazing session. Ladies and gentlemen, Shubham Agnihotri. Our next session explores how AI is revolutionizing safety in India's fast breeding reactors, a critical part of the country's nuclear program, highlighting AI-driven innovations such as early detection of hazardous gas during sodium disposal, real-time monitoring of sodium leaks, and so on. Our next speaker, Mr. Muthu Kumar Ganesan, is a scientist at the Indira Gandhi Atomic Research Center, Government of India, with over a decade of experience applying AI in automotive and nuclear sectors. His work focuses on safety automation in sodium-cooled reactors, including leak detection, predictive maintenance, and autonomous fire mitigation. Ladies and gentlemen, please put your hands up for Mr. Muthukumar Ganesan.
Quick check. Is it audible? Okay. So, good afternoon, everyone. So, it's a post-lunch session. I know it's very hot, so I try to make short and make it interesting as much as I can. So, let's dive into the topic. So, before going into the topic for today, I'd like to start with a small story. So, in 1986, a crew of scientists were preparing for a safety test in one of the famous nuclear reactors. So the objective of the test is straightforward. So they wanted to bridge the time gap between the grid failure and the diesel power back generator to come alive. So especially they wanted to keep the coolant pump, which is one of the critical component in the nuclear reactor. So they wanted to keep it running all the time. So this is the objective. So when we have the grid power turns off, it has almost 60 to 70 seconds to wait for the diesel generator to turn on. So they wanted to keep the free running turbine power to feed back to the coolant pump in order to mitigate that time gap. The test looks simple, but it involves a lot of critical steps. So the very first step, what they did was turning off an emergency cooling system. So it is one of the critical safety net in the nuclear reactor in case of any failure or in case of any emergency mitigation. So initially the test was planned to be executed in the morning shift, but due to a lot of some non-technical hurdles, they have postponed the test to the night shift, keeping that safety net off for such a long time. So when the night shift took over, they have very less number of scientists and under pressure and with less experience, still they wanted to continue the test and complete it before the next shift takeover. So they started making decisions wrong one by one without realizing the mistakes. So even they have violated a lot of safety protocols, and even a lot of safety alarms have been ignored, assuming that it is common in such safety test scenario. So at the end, out of control, the reactor becomes so hot and it becomes exploded due to the hydrogen generation. Because of that, the radioactive has been leaked to the environment, leading to a disaster. So it became one of the darkest history of running the nuclear reactors. So the incident is nothing other than a Chernobyl incident, which is caused due to the reduced power operation. It has been reduced by the operators and turning off the emergency cooling system and removal of the control rod to the unsafe height. So the consequences are generation of hydrogen gas and leads to an explosion and radioactive decay to the environment. So the later investigation indicated that it is due to the series of human mistakes and the instrumentation faults has been the major cause of this particular incident. So now imagine we have an AI technology back then, a predictive model could have forecasted an unsafe operating conditions, or a simple anomaly detection model could have highlighted an unusual pattern. Then the history could have been different, and we may not be talking about this incident today. So actually speaking, they wanted to improve the performance or improve the safety of the reactors. So running safety experiments is really hard. Actually, it is not, at least now. So I'm Muthu Kumar. I'm currently working in Indira Gandhi Atomic Research Center, focusing on AI-driven solutions for enhancing the safety of the nuclear reactors. So we do also run a lot of safety experiments. So what are the ways that we can do that instead of running directly on the nuclear reactor? What are the other solutions to do that? The very first way is developing a physical model of the real component or the real system. So what is meant by a physical model? If you assume, or let's take an example of a motor can be represented as a mathematical equation of resistance and inductance. So we can simulate the exact functionality of a motor with the equivalent circuit. So we have a real asset, and we can develop a physical model using a lot of mathematical equations and the physics-based models. So instead of running our test directly on the real asset, we can run our test conditions directly to the physical model, and we can analyze the results. But will that be a foolproof? Not really, because the physical model will be having a lot of assumptions about the real system. So if we want some outputs which has to be exactly similar to the real asset, then those assumptions has to be eliminated. So the very first step, what we did was connecting a line directly from the real asset to the physical model through sensor data. So with this, what the physical model sees is it can understand the real operating conditions or the real environmental conditions of the real asset, and it can take that as a blueprint, and we can run that safety test or test conditions on top of it. So it helps to reduce the assumptions, but does not fully reduce it. So this particular concept is called digital twin and has been used predominantly in the industrial systems right now. So now it has been seen as an open loop, but we can extend this functionality to a closed loop so that we can have an additional functionality in top of this particular digital twin. So with the real computation power, the complex computation power that we have right now in our hand, what we can do is, let's say if an operator wants to change a parameter, for example, changing the flow rate from certain 1000 tons per hour to some 500 tons per hour, instead of running that particular change directly on the reactor, he can run it directly on the physical model. He can see the performance, and that model will update the parameters back to the real set if it does not forecast any failures or does not forecast any anomalies. Whereas if it raises any anomalies, a human in the loop will be notified or warned that there will be some problem with that particular parameter change. So this is the actions to the plant. This complete cycle has been called as a digital twin, and we are currently using that digital twin concept to run our safety experiments. But where is AI involved here? So there's a concept. It just takes in the sensor data and performs an analysis and then updates it back to the plant. So with the help of AI, we can improve the performance of the digital twin to the next level. So let's take an example of estimating the temperature of the physical asset. So basically, it can be estimated based on this mathematical equation. So the mathematical equation does not consider any unexpected wear or any anomalies. It just considers the time over which the system is going to be run. So there will be always an error associated with it when we run any system. So we wanted to eliminate this error. This error actually happens because of the lot of assumptions still we have in our model, even after having the digital twin. So what we can do is, since we have a historical data, since we are running our nuclear reactor for such a long time, we'll be having almost 10 to 15 years of data in our hand. If we can able to develop a data model that can exactly simulate each and every component inside the real system, then we can feed the sensor data, the supervised sensor data to the data model, and it can able to predict the errors. So this kind of modeling is called residual modeling. So with this technique, we can able to eliminate the error to the maximum extent. So with this, we can eliminate the assumptions as well. So instead of a digital twin only with a physical model, we can side by side, we can have a data model for each component that interfaces and averages out the errors between the physical and the data model. So the data model that we have prepared can also be extended for other purposes. So this is one of the machine health profile. So the machine starts to deteriorate over the period of time, but not all the machines, or even the same machine with a different unit does not follow the same profile. We do not know, because it may be operating under different operating conditions, different environmental conditions, different parameters. So we cannot able to estimate the healthiness of the system. So that's why we used to have a periodic maintenance schedule for most of the components that we have. So if the periodic maintenance would be sufficient for any system, then we would have not seen any failures due to the instrumentation or the component failure. But we are still having a lot of failure which is happening because of the faults. So we need to go beyond the periodic maintenance schedule and find an alternative. So for that purpose, we have used a technique called remaining useful life estimation. So what does it mean? Let's say if I have a component which has been running for almost 5 years, I can estimate the remaining useful life that the component can run without failure. So that time difference we calculate as an absolute value. It may be in days or in weeks or in months even. So what is the importance? So it is very much important for two reasons. One is for the unexpected wear or anomalies which happens, which will not be captured by the regular time-based deterioration profile. And the another design constraint is specifically for our purpose, like nuclear reactor purpose. Let's say we have different components, but the state or the condition of each component are estimated based on its feedback from that component alone. For example, if I press a button to turn on a light, then we'll take the feedback from the light whether the light has been turned on. So this is how we complete the loop. So, but here in a safety critical environment, we cannot have any design constraints or design errors. We should eliminate the design errors, design constraints at the very early stage. So for that purpose, for example, if we take an example of a 3-mile incident in nuclear reactor in the US, which has been triggered by a simple stuck open failure of a valve. It's a very common failure, how that has been overlooked. When the later investigation indicated that it already had a self-check mechanism has been routed to the control room, but it was how it was missed. When they go for a deeper investigation, they identified that it was a design problem of the control valve itself. The control valve feedback does not comes from the real state of the control valve, whereas it was from the control input. So the control input is trying to change the state of the valve, whereas the valve is not changing its state. So since we are depending only on the feedback for that particular component alone, we will be ending up with such problems. So if we have a data model, the data model does not see the condition of that component alone, whereas we can estimate the functioning of the particular component based on the overall system behavior. So for these two purposes, we can have the data model that can able to predict the remaining useful life. So REL estimation, we tried with different techniques, and then we end up with doing with machine learning algorithms. But here, this particular problem comes under a supervised learning problem. So we need to have a lot of data associated with the failure. Since it's a critical component, we may not be running our system to fail so that we can record the data. So for this purpose, we used our digital twin, whatever we have prepared, and that digital twin will generate the data with the failure information. So all other steps is going to be same as such in other industries, whatever they are following for any other machine learning algorithms. For example, data pre-processing or model development, evaluation, and then retrain based on the validation result is not satisfied, and then the deployment. So the deployment also has a different strategy for this particular safety critical environment that we will be seeing soon. So before going to next topic, I would like to explore what is the nuclear program of India and what Indira Gandhi Atomic Center is working on. So the nuclear program of India has been divided into 3 stages. So in the stage 1, we used to have a pressurized heavy water reactor that takes in a natural uranium as fuel, and it generates energy. But the problem with this particular reactor is it has been the efficiency of this particular reactor is lesser than 10%, which means the fuel which has been burnt in the PSWR are having still a lot of potential to generate more energy. So and then the PSWR has been, we are deploying the PSWR in different places with the help of other countries. So that's where the second stage, the Indira Gandhi Atomic Research Center we have been working on, the fast breeder reactors. So it takes the used fuel directly from the first stage reactor and has been fed to the fast breeder reactor. It generates energy. Along with that, it generates fuel as well. So the advantage of this particular reactor is we do not need to depend on any other countries as we do not have an enrichment facility available. So the output of this particular reactor has been given to another reactor that also been feeding to can be used in another reactor as a fuel directly without any pre-processing. So why we are talking about this? So in the fast breeder reactor, we can assume a reactor as a two-stage device. It will be having the heat generation and the heat removal. The heat generation part has been taken care by the fuel with the fission reaction. The heat removal part has been taken care by the coolant pump. So here in the fast breeder reactor, we use sodium, it's a liquid metallic sodium as a coolant. It's a very good, it has very good thermal conductivity, very good hydraulic properties, whereas it is highly reactive with water and air. When it reacts with water, it generates heat and also it generates hydrogen. Hydrogen may be used, is required for the country for moving from one fuel to another, but hydrogen is very much not required for the nuclear reactor, because hydrogen has a capability to explode the complete vessel, then the radioactive decay can be easily reach the environment. So since it is generating the heat, it means it is getting, it catches fire, since that has a hint to us, so that we can implement certain methodology to monitor whether any sodium leak or sodium related discrepancies are happening inside the reactor. So we have a 3 broader applicability of the modeling that we have and has been used in different places of inside the nuclear reactor. The first one, the fire detection model. So fire detection is the general model that we developed, and it can be deployed for sodium leak detection. Since when the sodium leaks to the environment, it reacts with the air, catches fire, generates hydrogen. So that fire can be detected so that leak detection can be identified. So currently, the leak detection has been doing with contact-based sensors, whereas with this technology, we can go for non-contact-based methodology. So, and then the hydrogen deflagration is an event which happens during the sodium disposal scenario, where when the hydrogen started catching fire. So we wanted to see that particular event. If that event happens, we have to turn off or take mitigation during the sodium disposal plant. So the hydrogen deflagration happens in less than a half second. So we used to have a high resolution and high-speed camera imaging to capture that event. So we use a normal fire detection model using CNN, and we can use a segmentation model for, we are using segmentation model for the hydrogen deflagration with high throughput rate. So on general scenario, we can implement this model for fire breakout scenario throughout the industry, throughout the plant. So and then we predominantly use a sequence modeling technique since we are dealing with sensor data. The sensor data we have to analyze based on the sequence of patterns. So we use for sensor data analytics, we use this modeling, and then identifying the pattern recognition. Even when there is a video, for example, if you want to detect hydrogen deflagration event, it is going to be the second step in detecting that event, because it is a sequence of frames, we have to detect it. So and then video analytics purpose, currently we are not using it right now, but it can be extended for monitoring purpose. So and then the reinforcement learning, this one we predominantly use almost in all of our systems where we have an automation control. So whenever we wanted to control, let's say if I want to control a pump, if I want to control a temperature controller, I can use this reinforcement learning technique. It is based on reward and penalty based method. So this can be used in autonomous robots, and then we are currently using in the process optimization, and then even fine tuning the parameters of the PID controllers. So the deployment strategies. So the deployment strategies can be easily related to an analogy of an one story. Let's say there are 2 friends who are traveling in a bus. So one of them has bought 2 tickets instead of 1 for him. So the another one was surprised and asked why you bought a duplicate ticket. He told, what if in case if I miss 1 ticket? And then the another friend got frustrated and asked him, what if he miss both of them? Then I have already a bus pass which is renewed every month. So it seems to be a funny story, but this is, he is true in case of an uncertain environment where the reliability has been given the more preference. So the exact same methodology we use it for deploying any models which is going directly to the production. We use sensor data, we just take the sensor data and develop a machine learning model, let's say model A, and then we deploy it in the hardware unit, let's say hardware 1, and then I go for redundant deployment. So I'll be having same sensor data, and then I'll be having the same model, model A, but I'll be deploying it in a different hardware unit. It's not the different core, it's a different hardware unit separated out from the first board. So this one we can relate it to what is meant by the duplicate ticket. So and then the diversified deployment will be having a different data source with same sensor, maybe different sensors of different technology. Let's say if I wanted to measure temperature, the first one uses thermocouples, then I'll be using RTD in the diversified deployment. If I have a transmitter-based pressure transducer, or else then I'll be using piezoelectric-based transducer in this particular diversified deployment. So that if one technology or one technique fails, the another will capture the particular event. So and then we go for a completely different model. So we'll not use, for example, if I use a model A, let's say as a random forest, I cannot use this random forest in the model B. I have to use a completely different architecture. For example, it may not be decision tree as well. I have to go for even deep learning models or something like that. So, and then I'll be deploying it in a different hardware. The hardware also needs to be as much as different as possible. For example, the hardware 1 and 2 follow some architecture. The hardware 3 should be from a different architecture. So, for example, if I want to develop an end-to-end machine learning system, I have to, if I want to deploy that system, I'll be having a ton of workload just to, for the same output and for the same input, I'll be having different models and different deployment strategies to be used. And we'll be having a final decision logic. It will take, whether if it is classification based on the majority vote, or then if it is regression based, it averages out the results. And finally, since we are, there are no tolerance of error in the nuclear reactor deployment. So we need to have the system, which has to be, the decision-making system has to be highly interpretable. So currently we are working on explainable AI techniques where the models which is not explainable by themselves, we have to apply Lime or Shapely, thanks for that. And we are using such models to identify how the decision has been taken with a model, example in the CNN and other models. Yeah, that's about for the talk today. Thank you. Thank you, Cypher, for this wonderful opportunity. Yes.
You were talking about digital twin earlier in the beginning, second or third slide, right? So there's a normal model and then there's a physical model.
Right.
And there's one-way traffic, but then you put the feedback back.
Right.
But you still said that there's a scope of error still.
Right.
Why is there scope of error? And do you simulate, the second part of the question is, do you check something in physical and it's working well, but then you feed it to the actual model to see whether in the actual model also it's working well?
Right.
Suppose very high RPM and all that. So these are the two questions I have.
Yeah, so the first question, so you mean to say that we are feeding back to the model? What's the first question?
To the real model. So whatever you are simulating in
Right.
the physical model,
right.
in the digital twin you are sending it back to the physical model.
Correct.
But you are still saying that there's some scope of error. Why
Yes,
is there
actually speaking, it will just take in only the current state of the particular system. It does not eradicate the assumptions that we have about the system. For example, the assumptions in this case, what I'm saying is, let's say if it is wear and tear. I will not be create a mathematical equation for developing such wear and tear. Even if I develop a model, it will develop only based on a time-based scenario. So in order to eliminate such assumptions, we need to have, since we have the data already available with us, we can develop a data model. That data model can help us to reduce their assumptions so that the error can be eliminated. So the sec, 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 so.
10 minutes. That would be 3:40. Our next session will be starting at with some time. Okay. This dude. So should I tell them that we'll be starting at 3:30? All right, sorry. Ladies and gentlemen, we'll be starting our next session at 3:35. Also, announcement for the Hall 1. There's no treasure hunt happening at 4 p.m. It already happened today at 10:45 p.m. So you can register now for tomorrow, as it will be happening tomorrow again at 10:45. Registrations on spot. For updates, please keep an ear out for announcement at the Expo stage. So if you're interested, please do go ahead and participate in the treasure hunt, because this is going to be fun. I'll be seeing you all at 3:35. We're going to start our next session then.
Future looks like wow. Oh wow. It's like wow. Future looks like wow.
Once upon a time in the narrow streets of London.
It's like wow.
Tools, just sharing so much. आमंत्रित कर रहे हैं. मैं बहुत आभारी हूँ. अरे, ये कितने अच्छे आदमी हैं.
Call it in now, hit him with the best shot. Bring it in now, burn him with the high. Making moves, making moolah. Bada bing, bada boo. Catch a ride to the future. Let me introduce ya.
Aye, lad, there's magic in these old bones yet.
Watch out, big world. I'm small, but I'm mighty.
It's coming up right now. It's coming up right now. And it's looking like how? Future looks like wow. And it starts right now. It's like wow.
Hey, can I check the status of my order?
Yes, of course. Your order is due to arrive at around 2 p.m.
Oh wow. And it starts right now. Future looks like wow. Oh wow. And it starts right now.
Let us bring humankind together as one.
Future looks like wow. Oh wow. And it starts right now. Yeah. Future looks like wow. Oh wow.
EPAM India, one of the fastest growing advanced technology companies in the region. A modern engineering partner to more than 175 global clients across industries, helping them accelerate at scale and advance on the technology curve, one innovation at a time. We are located at Hyderabad, Bengaluru, Chennai, Gurgaon, Pune, and expanding to new cities with key capabilities around AI, digital, cloud, data, analytics, open source, and quality engineering. We built our culture around engineering excellence and drive it through our communities. We encourage our people to speak up and have a product mindset. EPAM India has been recognized as Best Workplace, GPTW, Best Company for Women by Avtar, Best Leadership Development Program for Middle Management. Outstanding contribution to AI skill development. We drive AI enablement differently, with more than 90% AI skilled associates and roles like Advanced AI Solution Developer. Our social responsibility and sustainability efforts, EPAM India contributes to Trees for Tomorrow program and supports Wild Wisdom Global Challenge, WWF, and help improve environmental literacy. We provide access to high-quality technology education for 15,000 plus students from government schools through eKids Digital Labs. We are the home of modern Indian engineer.
And I've seen this place grow from strength to strength. Speakers, the sessions, and the vibe around that.
Love the vibe. Love to see how big it has gotten over the years.
The largest AI conference in India.
Cypher has definitely attained a cult status.
Artificial intelligence.
AI. Coexisting.
AI.
India's digital future deserves more than imported infrastructure. It needs a cloud that's built here, governed here, always under your control. At NextGen, we don't just deliver cloud, we architect sovereignty, intelligence, and performance into every solution. Whether you're a government body navigating compliance, a bank juggling audits, or a startup scaling AI models, NextGen gives you the platform, performance, and partnership you need to lead. Our portfolio is unmatched. Speed Cloud, our public cloud, delivers industry-leading performance and savings of up to 80% versus global providers. Backed by OpenStack, RDMA, and blazing NVMe storage, it outpaces AWS, Azure, and Google Cloud in real-world benchmarks. Speed Cloud Supreme is your next-generation private cloud, on-premises or hosted. Built on Red Hat OpenShift, it gives you 24/7 fully managed operations, transparent pricing, and the ability to move from VMs to AI applications seamlessly. Financial Services Cloud is made for India's BFSI sector. 100% compliant, 100% Indian data residency, and immune to foreign laws. It's where trust meets technology, helping banks and insurers innovate without risk. Government Community Cloud is certified for India's unique needs, supporting everything from election analytics to critical public workloads. Mission critical, always on, and fully aligned with Digital India and self-reliance. Our AI-ready infrastructure is built from the ground up for scale and speed, delivering NVIDIA, AMD, and Intel GPUs on demand. Whether you're training large language models or deploying AI-powered citizen services, we enable your journey from provisioning to meaningful, real-world use cases. With our patented SaaS framework, you get a full-stack AI platform, from solution engineering to deployment to continuous improvement. Plug-and-play AI SaaS, custom model hosting, or scalable inferencing. Just pick what you need. Security isn't an add-on, it's at the core. NextGen delivers defense in depth, AI-driven threat intelligence, and full compliance with Indian regulations. With 99.95% uptime, disaster recovery options, and geo-redundancy, your workloads stay safe, compliant, and always on. And unlike black box clouds, you get true visibility, telemetry, logs, and full access at every layer. This is cloud on your terms, modular, open, and always sovereign. With NextGen, you're not just choosing a vendor, you're gaining a partner dedicated to India's digital destiny.
Customers care. They care about their health, their nutrition, their cravings, their habits. They care about what's familiar and what's exciting. About eating right and eating well. About celebration and routine, comfort and discovery, taste and trust, all at once. And when customers care this much, so should we. We have already made it easier than ever for customers to get the food they want, when and how they want it. Convenient, fast, efficient, undeniably powerful. But now, it's time to move beyond convenience and bring soul into every experience. And that's why our vision is to build technology that cares for the customer, with intelligence that adapts, with rewards that delight, with systems that move fast but always feel thoughtful. Because food is personal, and so should be the experience around it. With our thoughtfulness, we are engineered to deliver value at every level. At SmartQ, we're not just building for what's now, we're building for what matters next. SmartQ, built for the customer, built for experience, built for what's next.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption.
Ladies and gentlemen, we'll be starting with our last session. I hope you've gathered every minuscule of energy that you have right now, because we know that this is wholly and solely a cerebral session since the morning. In our last session of day 2, we discovered the future of India's chip design with a focus on AI-optimized processors, built to accelerate workloads and enable efficient computer vision at the edge. This session highlights the launch of India's first high-performance MCU, Secure IoT, and upcoming Vision SoC. Shashwat TR is co-founder and CEO of Mindgroove Technologies, leading the development of India's pioneering indigenously designed chips for the IoT and vision applications. For our last session of day 2, let's welcome on stage Shashwat TR, everyone.
So this is my topic. And just to quickly introduce myself and introduce what we do, we are a fabulous system-on-chip design house based out of Chennai, incubated at IIT Madras. And I'll briefly describe what system-on-chip is and what fabulous means, right? So, how many of you remember the computers of the 90s? The big clunky boxes, yeah. That entire system on the board getting shrunk into a single chip is what we call a system on chip. And what does fabulous mean? It means that we purely design the chip. The whole semiconductor industry is split into design and manufacturing. So nobody who designs actually manufactures, and nobody who manufactures actually designs, even if they work for the same company. So Intel, for example, designs and manufactures their chips in-house. That's called an IDM. But the foundry division and the design division are separate. Most other companies you've heard of, NVIDIA, AMD, Apple makes their own chips, of course, so are all fabless. They do not own their own foundry. The three that I named use the same foundry that we do, among others. So we are incubated at IIT Madras, and we also have approval for the second chip that we are developing from the Government of India under the Design Linked Incentive Scheme. So there's a lot of support that we get from that. We call our brand Mindgroove Silicon. It's not just chips that we make, we also make boards and we make other things. We make modules for people to deploy single board computers and so on. But the chips themselves are branded under the title of Mindgroove Silicon. Our first chip is a high-performance microcontroller. In a sense, not really relevant to the topic here because it's meant for controlling small devices. But it can run certain things. The second family is called Vision SoC, and it is an edge vision chip. It's not a full compute chip, but it is an edge vision chip, and it can do a lot of things that you guys might be interested in. And a little bit about myself. I'm not going to apologize for saying I'm an AI skeptic today. You'll see why going on, and I swear that this has relevance to the topic we're going to be discussing. I'm an electronics engineer. I did a lot of work in ultrasound, in X-ray, in a lot of vision processing. That's been my passion. So what am I doing building chips? I am an electronics engineer. I've done everything in the stack from JavaScript down to pushing atoms together. And right around the time of the pandemic, we ended up in a situation where I wanted to build something. I wanted to build some imaging devices. I did not find the chips for it. And we were staring at each other, trying to figure out what to do. Professor Kamakuti, who's now director, he was not director of IIT Madras back then, but he's now director of IIT Madras, basically encouraged us to take that matter into our own hands, showed us a bunch of other people who are having the same problem and said, basically, you guys have the ability to do this. Why don't you get a chip out? So we started doing that. As a result of having started a semiconductor company in the year 2021, just as the AI boom was picking up, everybody came to me and said, will you make an AI chip? Or what AI chip are you making, to be more precise? And here I am. I will tell you stories about why I am, but I don't believe in, or I don't blindly believe in the AI promise. However, I'm a hopeful AI skeptic who sees real possibilities and real potential, and I really want to solve the problems that I see with current Gen AI. And I think that one of the keys to building that out is to go to work on the hardware. And this is why I'm an AI skeptic, okay? I will go over the story. This is what we grew up with. I'm a kid of the 90s. This is what we grew up with, right? This is what we thought AI would be. Scary, in one word. It would be mathematically, logically brilliant. How many people remember pretty much every science fiction story had an AI that would say, does not compute? We expected that they would be extremely literal. And this is from War Games, but the alternate picture that I wanted to use was Captain Kirk talking to a computer and shutting it down with logic, which happened about once every 3 episodes. And we also expected that they would be unemotional, very, very straight, and HAL 9000 is a classic case, emotionally stunted. And really, all the AI horror that we have been fed, and all the AI promise that we have been told, was out of things like this, right? How much has our cultural ethos about where we are going to go with AI been about this? But that's not what we ended up with. This is what we ended up with. We ended up with an AI which can draw and paint and color, which can make movies, which can write scripts, which bullshits. We did not expect that we would end up with these guys which would, we thought it would be literal. It is not. It bullshits all the time, and it can't do simple math. What's going on with this, right? And part of what is happening here, it is cognitive dissonance for me, and I kind of dived into it to understand what was going on. And what happens is actually what we're looking at is a kind of architecture, a way of dealing with data, which is extremely statistical and extremely probabilistic. Therefore, it is approximate, and because it's approximate, it ends up not being exact and accurate as we expected it to be. Part of that happens to do with the very foundation of logic that we chose, one of the foundations of logic that we chose, which is the floating point arithmetic, which there is an entire, I think it's a 90-page document which says what every programmer should know about floating point accuracy. But that's not the only thing, right? It's a brilliant tool. We have I'm just going to talk a little bit about just India, just talking about who we are, where we are right now, and what we're going to talk about, what we're going to build for ourselves. Leave alone the way that people are trying to deploy AI in the rest of the world. Let's talk about what the promise for us in our economy is. We have a huge population. The word population got lost there, I don't know. We have a huge population. We are very successful in a lot of things, but we have very low productivity, which is keeping value locked up. And this is exactly why I see that promise. We need to go into a higher value economy and not just be doing base work. I see automation, not just automation at the physical level, not just robotics or not just assembly line automation. I see automation at the level of intellectual work also as a promise to be able to move up this productivity value ladder. One of the things that I used to do is so the last session was about nuclear power, right? And I used to work with the organization which was presenting earlier, and we used to supply some things for them. It has been so long since I saw that particular diagram and very nostalgic. But having worked in that field, one of the things I learned is that 90% accurate. You have to be 99% accurate. Forget about false negatives. False negatives are 0. And false positives are 0.1%. That's the scale that you expect. You pitch an algorithm which is 75% accurate, generates 25% false positives and misses a few things, they will reject it. Nuclear power, aerospace, all of these are not healthcare. These are not places where we can afford mistakes. And what we are looking at when we do that, sorry, I will come to this. What we are looking at when we do that is we are looking at other kinds of algorithms. We're looking at not just LLMs. And that is basically what I'm trying to say over here. Now, one thing that science fiction got right about AI. AI needs power. How much power? Lots and lots of power. There is a certain attractiveness to the idea of using the demographic dividend and not doing that monkey work, right? And not deploying an expensive AI resource to do this stuff, right? I can employ 20 people at even decent wages. All they need is this much power. One full meal in the afternoon, a little breakfast and a little lunch. How much does AI need? Google is literally trying to build a nuclear power plant. So, if we want more accuracy, it takes more power. If we want more power, we need, in a country like India, which has power problems to begin with, where are we going to get it? So there are ways around this, and there are ways to go over this and build around this. And why I think it is important is because of this very simple reason. We were doing inspections of aerospace casting components maybe about 7 or 8 years back. And you have assembly line which is turning out, let's say, thousands of components an hour. And there's this guy sitting and X-raying each of these components. Already the manufacturing line is so good that you get maybe only 1 out of 1,000 pieces which are defective. You do not want to miss that one piece. This guy is sitting there and watching these things go by one after the other, one after the other, one after the other. His job is to flag when he sees that something is. What happens is the guy gets tired and he starts making mistakes. And so the inefficiencies start creeping in. You need more people to do it. You need people sitting and doing this, highly trained resources sitting and doing this. And we need that accuracy to come in, which means we need to deploy these kind of things. Or do we? Yeah, do we have enough power? The thing is, the way that we built today, If anybody has, I know a lot of people have deployed models at the usage side, but if you go back, you will see that the base of pretty much everything we do today is that equation on that expression on top, a dot x plus b, which is a matrix multiplication offset by constant. We do everything as matmul, and the reason we do everything as matmul is most of the operations, like 95% of the operations that we actually want to do, are reducible to a matmul. And the reason why we want to reduce it as a reduce it to a matmul is because me, as a hardware engineer, I will tell you this. You guys can come up with the algorithms as fast as you want, including me. I can come up with the algorithms as fast as I want. But to build a chip, forget the design process for a minute. Just to take a design and fabricate it on a wafer of silicon, just imprinting the design on a wafer takes about 3 months. And then there is all of the logistics time, packaging it into the little plastic box with the metal leads that you see, or the ball grids that we see. That's called assembly. And then there is another phase of testing those chips. And then there is all of the supply chain side of shipping it from the foundry to a fabless semiconductor entity's office. And then you actually build the boards, put it on a, you're talking about 6 months, 8 months delay easily. I can't ship a patch. And so we try to get down to the bare basics of the kind of hardware that we can actually build, which can be deployed generically to all of the applications that we want. It so happened that there was one architecture, never built for AI, never built for computation. It was built for an entirely different kind of computation, which got deployed almost accidentally to compute for scientific applications, and that was GPUs. We, growing up, used GPUs to play games. And at one point of time, this is around 2007, I believe, NVIDIA guys see a science lab in Europe buying, I think it was CERN, but don't quote me on that, I don't know for sure. I don't remember for sure. They see somebody buying a bunch of GPUs. And Jensen Huang is very curious, and he directs people to go and ask them what is going on. So it turns out that they're writing GPU shader code to do scientific computation. From that, the idea of CUDA was born. I've used CUDA to process scientific data, to process ultrasound data, to process X-ray data. I've used CUDA for rendering. Well, I've used GPU for rendering. Then it turned out that one of the things that you need to do for really good GPU rendering is matrix multiplication. And the guys who were building neural networks found that they could easily adapt the math to become matmul friendly. And then they deployed it on GPUs. It was really good. It worked really well. And it just, basically that's how it took over the world. Even the GPU is capable of a lot more than matrix multiplication. That's how I used it. It's capable, for example, of Fourier transforms. It's capable of other kinds of computation, which is what we used to do with it. But it creates a couple of other problems. It hugely, because you're doing matmul, you need to have that dense matrix of numbers, X by Y grid. And you have several, the layers of a model are each sets of numbers, sets of matrices which get multiplied successively and applied to the input data, right? So models become big. A lot of the places where we want to deploy, a lot of the places we want to automate you cannot have a 70 billion, even a 7 billion parameter model, right? Even if you're using a single 8-bit data type to encode a 7 billion parameter model, that is 7 gigabytes of memory. Now, it's not just a question of storing that data. It's a question of taking it out of wherever you're storing it, bringing it to the processor, running the algorithm, pulling the next piece of data, pulling the next piece of model out of the data store, running the model. So that's why you see chips becoming faster and faster. That's why you see people trying to race down to 2 nanometers and 1 nanometer. Because the smaller your chip is, the smaller your transistor is, the faster it can switch. And so you're just trying to shove data as fast as you can into the compute pipeline. And the compute pipeline itself is fast enough. The problem is the data coming to the pipeline and the data going out, which takes power. So you can choose to do 2 things about it. You can choose what algorithms you deploy, the kind of algorithms you build, and you can choose the kind of architectures that you build. Right now, up to now, the algorithm side has been moving so fast that it's really hard, like I said, because it's at least 6 to 8 months, even if you have a ready design to put it into production. In 8 months, a new algorithm has come out and the hardware, fine-tuned piece of hardware has become obsolete. So the hardware engineer's dilemma is this: do I build for now, or do I build for 2 years down? If I'm building for 2 years down, how do I predict what is going to happen 2 years down in a field that changes every 2 days? But we have learned a lot in the last 10 years of design for AI, starting from the GPUs, and Google started building tensor processing units. And I will come to the TPUs in the next one. But right here, we have many other techniques besides LLMs. Right? We have all of these things. These are considered AI. Support vector machines, convolutional neural networks, RNNs. All of these are considered to be AI. Even a decision tree is considered to be AI, and it's a hugely useful piece of equipment. I'll use an analogy to the human body, right? Let's say I'm throwing this thing and catching it. How much of the action of throwing and catching actually went to my brain? There is a hand-eye coordination which is happening, but it doesn't, I'm not reasoning it out. I'm definitely not putting it into language and throw it and catch it. When you catch a ball, you just, right? And let's say you touch something hot and you pull back. What is happening there? That's a spinal reflex. There are still neurons over here. There's still intelligence happening. It is not cognitive. Language is used only up here. Not everything reaches up here. So if you think of the kind of systems, let's say you're deploying an industrial system. Let's say you're deploying it in a nuclear reactor, again, to give a lot of the systems need to react at split seconds. You don't need to take all the data back out to the central processing system and bring it all the way back as control. What you need to do is you need to have reasonable intelligence happening at the edge. So incidentally, one of the things that we did, one of the reasons that our microcontroller is 700 megahertz, it's high performance, is so that it can do this kind of work at low power at the edge for small amounts of data. Even for maybe a little bit of audio, but no more than that. So you need zippier stuff. Here, I will put on my skeptic hat again a little bit and say that I don't necessarily agree with provisioning very large neural processing units on microcontrollers I'm going a little bit deep into the weeds over here. I just want to make this point. I don't necessarily agree with that yet, because they become generic, they become big, and they become impossible to deploy at the cost factor that you want on the edge. But this is the kind of thing that we need to look at in terms of whole system architecture. Give you another example of vehicle, right? A car. We have ADAS. Right now, driver assist systems, pretty much the vehicle architecture is made up of what is called a domain controller. So you have one controller for the powertrain, you have one for the brake, you have one for, let's say, the steering, the lighting, the infotainment. The automotive world is moving to a kind of architecture called a zonal architecture. So where you have compute unit for the front left, front right, back left, back right, center. And if you have a brake over here, that is controlled by this zonal controller. If you have a brake over there, that's controlled by that brake controller. But you have brakes and lights controlled by the same thing. And here we run into a problem called mixed criticality. The brakes are more critical than the lights. The engine is more critical than anything else. The engine is more critical than the infotainment, for example. So, but you have all of these things running on the same device. So how do you solve for that? Here again, it's a question of how we design these systems as hardware engineers to be able to handle this mixed criticality and such that one component does not affect the other. So that is in terms of algorithms. You can do any number of things to select algorithms. You can select algorithms which are less complex, which get the job done. And for example, there was one recent, not so recent, maybe about a few months ago, piece of research that I heard of using an LLM to train a classic algorithm and get its weights and its get a fixed function accelerator trained with its weights and everything else, so that it can actually tackle the job at hand. But you use use an LLM or use a CNN or a much higher form of AI, more cognitive form of AI to train the lower form of AI. That's actually intriguing to look at. In terms of architectures, in terms of my domain, right, my current domain, we have three ways of doing this. There is the fixed function accelerator, which is what Google calls a tensor processing unit. The most famous of this is the systolic array. There are other forms such as vector engines, which is something that I like a lot. And there are a bunch of other fixed, like you can literally fix the math over there. Now, what is happening with the TPUs is they're really expensive to make. Only Google can afford to make them. And they're really impossible to program for anybody who is not Google level engineer. The other problem with the TPU architecture today is that you get a 100 TOPS TPU. This paper which I'm talking about, which came out of Google, which came out of which was supported by Google, and it was collaborated by the guru of computer architecture, David Patterson. They found that the current generation of TPUs at that point was using only 20% of the operations that were provisioned in the compute system. The rest of it was just going to moving memory up and down. So you build a really powerful TPU, you build a very powerful fixed function accelerator, but then you're not able to get data to it. What's the point? So is that the best way? If you can get the data to it, it's probably the most efficient way to do it. As long as you're digital. I'll come to that. The GPU style, general purpose, GPUs have a reputation for being hard to program. But trust me, they're easier to program than this stuff. to date, a lot of people have tried to do training on fixed function and training on TPUs and systolic arrays. And I'm seeing a lot of people, I used to see a lot of people saying we are going to build for that. And over the last couple of years, accelerating over the last 6 months, I've seen a lot of people giving up on that dream and saying, we're going to use the fixed function accelerator purely for inference, and we will train on the GPU. GPU still to date, nobody has found a replacement for the GPU for training. The third there are other ways of doing it. The third one, which is interesting to me, is neuromorphic computing, which is kind of mimicking the structure of the brain. The fundamental difference that you should know between the systems that we have built to date and deployed and the human brain is that the human brain is analog. And it is multi-signal. There is no single signal path. So neuromorphic computing attempts to bring that analog nature of the human brain to silicon and uses very old techniques dating back to the 1940s of doing analog computing. It will sip power compared to the stuff that we have right now. But it is incredibly hard to build, and there are no products out yet. Unfortunately, to date, all the neuromorphic algorithms, neuromorphic designs that we've seen are very fixed function, and they're not generic enough that you can deploy it on anything else. So no products are out yet that I know of which are implementing neuromorphic computing. So yeah, a little deep dive into each of these things, what I just went over. This is what a GPU looks like. This is what a current generation NVIDIA GPU looks like. This is a block diagram of the Google TPU, and you can see that big matrix multiply unit 64K per cycle over there. But you see all of this hardware around it to feed it with data. And all of this hardware around it is the stuff that really burns power. Yeah, neuromorphic. So this is the promised land. This is what we want, where we want to be, right? There are decades-old techniques which we can deploy today. We don't need to only look at the latest algorithms. There are decades-old techniques which are available to us to be able to move forward. Our algorithms are moving fast, and hardware is obsolete as soon as it hits prototype, forget market. Inference is still possible. Now it is becoming more possible to build specialized hardware for it. I would not touch the GPU in terms of training yet. We've seen a lot of hype. I think we are at the top of the hype cycle. We're coming a little bit down. But the hopeful skeptic in me says that the plateau of productivity is in sight, and we just have to hold on and get to the point where it is actually feasible to do really interesting deployments and actually see some real long-term value gain out of this. Yeah, thank you. Yeah, the last point I would leave you with is better, more efficient hardware is the way to get there. Thank you.
Ladies and gentlemen, we have a few minutes. If you want to ask any questions, please go ahead. Can we please pass the mic there?
Hi, my name is Anubhav, and it was a great talk. I wanted to understand that you spoke about a bit about the chips that you have created so far as a company, and the talk title is also about creating chips for the AI.
Yeah.
So is there, and I believe there is a lot more inclination towards edge AI is what, edge devices where we could run it. So in terms of that, have you already built, prototyped, and what are the limitations for the general purpose? Assume I'm not GPU fanatic, I'm not TPU fanatic, nothing. All I care about solving customer problem by the existing tech. So where does that, where is that space where I am interested?
So we are building ourselves up to the point where we can build something that is coherent and meaningful to be able to deploy in edge. Because I'm a guy who, this comes a little bit from my bias. I'm a guy who likes to work on the field, right? I like to have hardware. And so a lot of the problems that I'm interested in solving are on the edge. And so we're trying to build for that. The other thing is, there is an opportunity to do it. And what I would suggest is pick a problem. And we can have a much more detailed discussion on how to solve that problem. I am currently, I would really go against the idea of trying to accelerate LLMs at this point, or any kind of transformer at this point. It's not worth it. It is much better to look at all the other things that we are trying to solve and accelerate those.
Okay, I have one more question. So a couple of months back, there was a talk at IIT Madras about running local LLMs on commercially available Intel Xeon, I think the processor was, and they did a bunch of demos as well, and they said the models are quantized, they are open source, you can run it on commercially available hardware. In this perspective, that is also, it's kind of edge, I can run it on my laptop, but in your perspective, it's much more deeper, it's much more embedded device where I can run it, not just a laptop. So in terms of that, can you share where we are currently, not in terms of what you have done, but as an industry, maybe Chinese have done something around it, they already have Huawei, something of that sort?
So, I have actually run those models on commercially available commodity hardware. Because this talk was about building hardware, I did not talk about how we are using hardware in chip design, how we are using AI in chip design.
Understood.
But the answer to your question is I've seen some early results in deploying it on commodity hardware. There are various reasons why we would want to do it not at the server farm. The way I am defining edge is one step further to the actual devices that you hold, or a device which is actually performing one small task. So the answer to can you run it on commodity hardware is yes, because I have actually seen it happen. Maybe not the training, but definitely the inference.
And your target is not the LLM running on these, because you're obviously saying no to transformers.
I'm saying no to transformer today.
Today.
Okay. Maybe later, maybe if there is a reason for doing it. I also don't know if there is a reason, going back to that brain and spinal column analogy, I don't know if there's a reason to do it for the edge.
Maybe. Okay, thank you.
Thank you so much, ladies and gentlemen. If you have any other questions, Shashwat sir is going to be available on grounds. So please do make sure that you go ahead and...
Can I ask one question?
Yes, sir. Please go ahead.
This is Karthik. Couple of questions actually. One, do you have an estimate of the market size for such edge compute chips? Two, do you just make a chip and it finds applications in retail and auto, or do you have to solutionize or put an application on top of these chips, and do you do that?
I'll answer the second question first, and I think that will give you the answer to your first question. You have to be a lot more, the chip industry is very, very difficult because of the fact that we need enormous volumes. And because we need enormous volumes, you can't make anything so specific that it goes only into one vertical. You have to bunch a bunch of very close requirements together and build for that. So it is not so generic that you can just build a chip and it'll find its way anywhere. You have to spend time to think about how it's going to work. automotive is different from mobile, is different from server, which is different from industrial, which is different from consumer. That's just the way that life is. And because of that, there is a huge value, but it's very fragmented. And trying to build it with a one-size-fits-all doesn't work. Volume aggregation is a serious problem. It's a problem that keeps every semiconductor company's team awake at night. Product team awake at night, yeah.
Thank you.
Thank you so much, ladies and gentlemen. Thank you so much, Shashwat sir. Thank you. Ladies and gentlemen, we'll be having Honorable Priyank M. Kharge, our Cabinet Minister, Electronics, IT, BT and Rural Development, Panchayat Raj at Government of Karnataka tomorrow. He will be talking on Karnataka's Tech Vision, AI startups and innovation hubs. Also, I just need to inform you that at 4:30, 7 Olympics, 1 legend, the Leander Pease playbook is going to start. So this is going to be a session wherein you can ask him questions and get to know about a lot of things that you might have been thinking about when it comes to him. And also, Minsky Awards for Excellence in AI 2025 will be starting at 5:15. So do make sure that you become a part of these amazing sessions left for the day. Signing out, Shruti Tripathi.